Dr. Michelle Banawan is a postdoctoral researcher at the Science of Learning and Education Technology Laboratory, headed by Dr. Danielle McNamara of the Department of Psychology, Arizona State University. Her specializations include natural language processing and machine learning. At present, her work is focused on the application of machine learning algorithms, computational linguistics, and natural language processing to various components of the SOLET Lab projects within the context of reading comprehension and writing proficiency studies. She also handles data curation, data wrangling, and database management, which entails writing queries to address the different data requirements of projects. She also participates in the design of intelligent tutoring systems and educational games. Her specialization and skills include data and database management, design, analysis, and visualization. The data science and machine learning tools that she is proficient on include MySQL, Python, and R. She has also more than 10 years of experience in information systems analysis and design, business requirements modeling, human-computer interaction, user-centered design, and systems documentation, and teaching and mentoring students at the undergraduate and graduate levels, taking up computing and information technology degrees. Help me welcome our resource speaker for this morning. We are so grateful to have her, Dr. Michelle P. Banawan. Good morning, Ma Michelle.
Hello, good morning, Ms. Dana. And I'd like to greet everyone good morning. And I'm looking forward to a fruitful session, webinar session today.
Thank you, Ma Michelle. And the screen is yours now. And hopefully our participants are eager to learn what you would have to present for today.
Right, so once again, good morning, everybody. My name is Michelle Banawan, and I'm currently doing data science work since 2019 here in Arizona State University. So you would understand throughout the course of the webinar today what that actually means. And the webinar series that the DICT 9 and BASULTA has made available for everyone, for us colleagues and dear students, is about future-proofing institutions through emerging technologies. And how else can we future-proof ourselves, the institutions that we belong to, and our societies, then thrive with data science. So that's what we will be doing today. And so this specific webinar today is focused on future-proofing institutions with data science. What should you expect? So we'll look at data science in this big data era, and we will look at its anchors. So that's the first part of the webinar. The second would of course be data science fundamentals, which would entail concepts and some under the hood knowledge of data science. Then we will look at data science trends. Where is the future going? So will we still be able to catch up? How would data science look like in the future? And then finally, we will look at the different tools that you can use in doing data science yourselves. I would be amiss if I jump directly into data science without reviewing the anchors, why it came about. We know that we are already in the fourth industrial revolution, and we have been here in this fourth IR for quite some time, for more than a decade. And some would even say that we are already slowly entering into the fifth industrial revolution. The fourth industrial revolution is characterized by web-enabled systems. It's characterized by internet-based technologies and, yes, artificial intelligence. And so because of these platforms, because of these tools, we have found ourselves in the era where data is everywhere, and it would be a lost opportunity for people if they would not look at data and use data as the current currency. So with fourth IR, we would hear buzzwords like, aside from data science, of course, we would hear buzzwords like AI or artificial intelligence, machine learning, which is more of the computational part of data science. Then we'd also hear data fluency, or how you'd understand data to do some tasks like data analytics and everything with the word data in it. So they say that the biggest word in the universe is now this four-letter word, which is data. So before we diving into data science, we'd like to review the highlights of this fourth industrial revolution. We'd like to look at AI and its different phases in our daily lives and in society. So first would be AI and data science and machine learning, for that matter, has been imagined, but we thought that it was just a figment of the imagination, just fictional. Some years ago, I don't know if our younger audience were already born at that time, there's this movie that's entitled Minority Report. And that movie was kind of interesting. It was so unimaginable. And what happened in that movie, for those who don't know, for our younger sector in today's audience, for those who do not know what the movie is, it's about that society where it's a place where people get arrested by law enforcement agents for a crime that they will commit. They haven't done the crime yet, but because of this, the world that they live in, where they can predict everything in the future, like a person who's about to do a crime like 2 days from now or 3 days from now will get arrested. Now, it may sound silly and there might be some ethics and some debate over that, but it's like a foretaste of how prediction has evolved in today's society. Even towards the end, I don't know if you'd agree with me or it might be a refutable statement, even when we're here not at the onset of fourth IR anymore, we're nearing the end, maybe. Data science has fulfilled what was imagined. And there's also a later development on robotics. We know that robotics is also part of the fourth IR. But what is happening to our robots now? You heard of the term perhaps about empathic computing, where robots will be taught, where robots will learn empathy. And we get to teach them emotions, we get to teach them superficial feelings. So we do not have only artificial intelligence, we also have artificial affect. And that's the trend in robotics. There's also a series that I have been watching for some time, but it's not, it's an old series. It's the Big Bang Theory. And this is Raj. He's one of the nerds and geeks in this series. And in this episode, he was so in love with a voice assistant that voice assistant, for himself at least, for Raj's reality, came true and had evolved into a human persona, acquired a human persona. But that's just, that's of course far from reality. No, but what this slide is trying to point to is that is the sophistication of our virtual assistants and how they have become part of our lives. Like we talking to Alexa, talking to Siri, talking to Echo. And then there's this MIT project where in their deep learning lab, they have been trying to develop assistive technologies where they use deep learning so that people can hear with their tongue. But I don't have any updates as to how this project has developed. But this is a fairly old project. And one of the earlier projects of MIT for deep learning. But again, what are smart applications? So our applications now, the ones that we have in our hands, literally and rhetorically, are already smart. But now I feel that smart applications is already a misnomer. We should call these applications now as smarter applications. It has smart interactions. It will, given your routine, it will tell you that at this time of the day, like say in this apartment building, I usually go to a certain location at 9 a.m. And so when I have something that will prohibit me from doing that or doing any of my routine, my phone will suggest that you're supposed to be doing this. So we have smarter interactions with apps, with our handheld devices. We have smarter platforms. We have smarter processes that enable business agility. Agility is a key word when we want to future-proof ourselves and our institutions. When you are agile, you're not static. When you're agile, you're not sedentary. You're moving, you're going with the flow, you're riding the wave. Then we also have smarter security. So we have embedded computing that gets smarter and smarter. And then we also have what used to be Internet of Things. We don't refer to Internet of Things as just IoT anymore. We took intelligent things and the internet, these digital twins, and now refer to this as Internet of Intelligent Things. This is still the ubiquity of computing and it being embedded in our reality, in ourselves, in extensions of ourselves, like our smartphones, like our good old home appliance, security system. Then, of course, we also have augmented reality. And what better artifact to refer to augmented reality than the classic Pokemon games where everybody at some time, like maybe a couple of years ago, we were all looking for this Pokemon monsters on our phone. But augmented reality has exceeded just that level of augmentation. Okay. And then for our first webinar series, Professor Patrick Paasa, our very able resource speaker, made us appreciate blockchain. So I won't delve into that. With fourth IR, we have seen that disciplines cease to be on their own silos. They're not compartmentalized anymore. They have fused, they have overlapped, and their interplay resulted to the fusion of these disciplines resulted to new disciplines, and data science would be one of this. A characteristic of this phenomenon is that this emergent new disciplines resulting from the fusion of previously disciplines in their own compartments, in their own silos, this new discipline that result from this fusion will inherit the characteristics, the attributes, the body of knowledge of its parent disciplines. But at the same time, it has its own distinct identity, and that's what data science is. We can look at data science as blurring the boundaries between computing, between math and statistics, between domain expertise. But we'd be able to appreciate that on the second part. The first part, this walk down memory lane is a memory lane of AI, and fourth IR will just be a very short path. So this isn't data science yet. So who creates data? And the obvious answer is everyone should plead guilty. That's why we now find ourselves in this data lakes, in this data universe, because of certain technologies, platforms, needs, and prerequisites in life that we inadvertently create data and volumes of data every day. First, a highlight of this big data era and AI would be facial recognition. This feature, this smart feature, was not something that people of my age, when I was studying college then, could have imagined. No, I had my college degree a lifetime ago is computer science. So I studied computer science in Pamantasan ng Lungsod na Maynila. And it's just a brief anecdote. So why did I choose computer science? I don't know. It was really new then. I didn't know what it was. But when I was queuing up in the registrar's office, I asked the person beside me what he will be taking up. And he said computer science, and that sealed my destiny with computer science. But going back to this slide. So facial recognition would be one of the AI features that we now have considered as a norm. It's so normalized that we don't look at it as AI anymore. We look at it as a prerequisite feature in the apps on our phones, like even in social media. And because of facial recognition, what other AI trends or data science applications has facial recognition led to? Which, as a side note, facial recognition is a data science highlight at the same time. With facial recognition, we not only see features of the face, we not only see the contours of the face, but we see beyond that. We are able to look at constructs like a state or trait of the person owning the face. We are able, the machine, computers would be able to predict demographical data, like say, if the person in the image is female or male, if what race the person in the image is, or even detect and predict the emotional state of the person in the image. So with facial recognition, another highlight which has evolved from that is facial analysis. What other highlights can we see with the big data era? First, we have geotagging. So again, we plead guilty by producing lots of data. When we do like app check-ins on whatever social media platform we have, or even on our phones, when we take pictures, when we visit places, we also tag ourselves in this map and contribute to this data that's produced every second, billions of data produced every second. Because of geotagging, what highlight has again evolved from that. So we have path analysis, like say in sports, Path analysis is used to study future gameplays, no? Like say a soccer game or football or any football and soccer, or say basketball, and some other path analysis that's relevant to, our existence as humans. So those are highlights of fourth IR, AI, and data science. Then we have the metaverse. Some industries are so future forward, they have a good lens in seeing or imagining what the future is, and they see the metaverse. Now, some also say that metaverse is already one of the pedestals of the fifth industrial revolution, which would not be hard to believe or hard to imagine. But metaverse, like all good things, should not be rushed. We should have enough time, enough data to study the metaverse. Fifth IR and the metaverse is, as compared to the fourth IR, augmented reality, virtual reality, is putting in virtual reality and actual human reality in this seamless world. If in the fourth IR, we have our own real worlds, the physical world, we just plug in virtual reality, we just plug in augmented reality. The metaverse, we have such a blurred picture of what of the space that we exist in. And because augmented reality has mimicked and replicated reality so much and so accurately that humans are either traveling or incorporated in this metaverse, in this virtual reality. So there will be two coexisting entities in the metaverse, our human reality and our virtual reality. But then, even as we intend to take it as low as we can, the pandemic happened. And so, what has this caused? It has not, the pandemic did not, the pandemic was not anticipated. Yes, of course. But what we did not anticipate was that how man was able to augment reality and exist in a virtual world, in an augmented world. What were our crude attempts in defining our requirements for a metaverse? Say in Zoom meetings, we have our augmented reality, our virtual backgrounds. No, what's the intent behind creating those virtual backgrounds? We want to experience or at least have a feel or an illusion that we are somewhere else, say in the Bahamas, in the Caribbean, or say we're in our bedroom but we want to appear scholarly, and so we have like a library, or we want to supplement our stifled social life because we are in lockdowns. So we mimic a coffee shop, a bar, and those, because of the pandemic and how we reacted to it, how technologies reacted to the pandemic, we have slowly but surely approached the metaverse, but it's still in the corner. It's not as clear how the metaverse looks like just yet. So when we look at technologies, what do we really see? When you look at your phones, do you see the AI features that underlie apps in the phone? Do you see the features in the app. No, when we look at technologies, what we see would be ourselves. We are now, sad to say, or is it sad to say, is it a sad reality or it's a reality that we should be excited about? We are now seeing ourselves when we look at technology. When we go to TikTok, when we go to Twitter, we now see versions of people, egos of people. When we look at our own profile, that is me in my own profile. So technology and humanity, because of this fourth IR, because data has permitted how we live and dictated how we live too, we and technology seem to have that seamless boundary, seem to have to shift from our online selves to our physical selves. Sometimes we cannot discriminate anymore. So, how do we ride this fourth IR wave? How do we ride the fourth IR wave towards the fifth IR? How do we future-proof ourselves given a new dimension? How do we become, how do we claim our identities in a parallel universe? No? So by equipping ourselves with technologies that we have now and not stopping to learn. And so we are now ready to learn about data science fundamentals. If only I can figure out how to do it there. All right, you should see data science fundamentals slide deck now. So what comprise the data science body of knowledge? I've given a hint of this a while back, a few minutes ago. And we said, let's recall that with this industrial revolution, with this data revolution that we find ourselves in, there's a fusion of disciplines that give birth to an emergent discipline that is anchored on the body of knowledge of these original disciplines, but has its own distinct identity, has its own body of knowledge. But let us try and look at the overlapping disciplines where data science is anchored from. So first, what is obvious would be, I'll start with mathematics because I'm computer science, you might say I'm biased. So data science is really anchored on mathematics. It's anchored in measures of central tendencies. What are our measures of central tendency, dear students? Can you still recall for the students in the audience? Diba, we have our mean, median, mode. Why? Why is data science anchored on that? Why is it at all related to these measures of central tendency? It's because data science, modeling data, is always interested in the expected behavior, and we'll appreciate that as we go through this webinar today. So it's anchored on linear algebra, calculus, and statistics. Some statisticians would even say that data science is actually multivariate statistics. It's actually statistics with a new flavor. I tend to have to agree in some ways, but that would be statistics and more if it were up to me. The second body of knowledge is domain expertise. So you can see data science rarely existing on its own. We're working on, because the data comes from different domains, so you need domain expertise to be able to what? Ask the correct questions, identify the pain points of the specific domain, identify the goals of the specific domain. So domain expertise would be, say, business intelligence, that's a version, a subfield of data science. What domain expertise would you expect in business intelligence? Of course, business. Say, for example, bioinformatics. It would be something in the world of biology or medicine or the physical sciences. Now, the third body of knowledge is computer science, and that would be obvious for today because we'll have a foretaste of some of the algorithms, some of the computing tools used for data science. We'll have an appreciation of the computing part of data science also today. No? So that's what the data science body of knowledge is comprised of. So at least we're aware of that. So what are the use cases of data science? So in society, data science is a buzzword, but what is its actual use? How can I actually apply data science in my institution? How can I apply data science and benefit from it in my personal and professional pursuits? So data science requires this skill sets. So you need to have some hacking skills. Hacking skills will have some negative connotation, but when we say hacking skills for this slide, it's to be able to know how to work with, acquire, and manipulate massive amounts of data in all its forms of digitally conceived, digitally created data. And then you would also need some math and statistics knowledge because that's inevitable because as we have seen in the previous slides, data science is anchored on math. You cannot just apply the tools without understanding the math that underlies these tools, right? So it also needs substantive expertise in a scientific field. It's required to generate motivating questions and hypotheses and interpreting results. This substantive expertise would be more anchored or more aligned to that domain knowledge or domain expertise, no? And so that you'd know what would be an ideal growth rate, so that you'd know what would be an ideal accuracy for predicting a specific construct of interest. Then, of course, you need to have skills on performing traditional research because data science, after all, is an empirical field. No? So we have iterative experiments. Of course, you have to have machine learning, computational skills, programming skills. Not all tools, though, require programming, which you will see in the last series of today's webinar, the last slide deck. I'll feature those that do not require programming and some tools that are programming languages. And of course, there's a danger zone which we should be all aware of and not be too naive to ignore that. No? So that for our legislators in the audience, those who are part of governance, will know what vulnerabilities data science can bring about in society and in the ICT, in architecture or infrastructure of institutions and society, right? So, but another danger zone, before I forget, it's not only for governance, for regulation, but danger zone would also be applicable even for personal goals where you apply data science to, even for small and medium scale enterprises where you'd like to apply data science to. The danger zone is that we are so enthralled with the data that we have acquired and applying data science methods that we become victims of inaccurate analysis. And so we will have some form of misinformation when we create decisions, right? So these are data science skill sets that are expected of data scientists. It's a lifelong learning process. Now, there are different types of careers that's involved in data science, and one can be a data scientist, one can be a data engineer, one can be a data analyst. For some roles, most especially, I do not want to say most especially, perhaps even across the globe, even in my workplace, you cannot help it that you engineer data, you do data analytics, even if primarily you thought what you signed up for was doing data science work, or what you thought you signed up for was doing data analytics, you end up doing data science work. So how are they different? That's some reading, that's some offline reading, or we can tackle that in the Q&A later, or in DICT 9 and BASULTA's 4th day, which is the podcast. So this is a shameless plug. I hope to see everybody on our 4th day, which is a podcast, which people would be able to ask questions, I think. I'm sorry, I did not ask, but maybe that I'm accurate. Sorry. So the modern data scientist, this is another visual that illustrates the specific skills. So if you would like to learn how to be a full-fledged data scientist, these are the tools that you need. So say for programming and databases, you must have a understanding of computer science fundamentals, must understand data structure. You must also have proficiency in scripting languages. So you must know Python, because there's a huge community, a wide community of supporters on data science using Python. Then for statistical computing packages in R, which I'll also show you some R scripting today. Then of course, you'll do data pool, joining data, aggregating data, which would require databases. So you have your SQL, your MySQL, Microsoft SQL, Oracle, NoSQL platforms, but we'll have more of that tomorrow because those fall under the domain of data analytics, because data analytics somehow is a subfield or a component of data science, but it's a field on its own. So for those who are interested in understanding data, preparing data, manipulating data, and telling a story about data, that would be tomorrow's webinar. I made a mistake. Podcast would be day after tomorrow. Tomorrow is data analytics webinar. Okay, so you also need to have knowledge on relational algebra, so on and so forth. For math and statistics, you see here machine learning falls under math and statistics because you'll also appreciate that and understand that in the next few sessions. Experiment design, optimization, etc., etc. We will be discussing supervised and unsupervised learning in a few. Then domain knowledge and soft skills. passionate about the business or the institution that you're part of. Communication and visualization. I'll not read all these bullet points. All right, so let me check first. Sige, we have a few questions before we proceed. So I'm sorry for not addressing the questions earlier. I will go back to them. I appreciate the questions. When we ask how do we feel secure in a virtual world, what we are actually doing today, what we are actually doing for the past 3 days now, attending blockchain, cloud computing, and today data science, tomorrow data analytics. This is learning more. This is equipping ourselves. This is acquiring the tools. This will make us secure in that virtual world and even in the not so virtual world that we exist in. Should we be equipped with a background knowledge on all this body of knowledge for us to be able to start a career in the data science? Brutal answer is yes, but we can learn them a bit at a time or on a as needed basis. So just learn what it is you need to learn to get the job done, but always put it on the horizon, on your vision boards, what you are picturing yourself to be with all these tools, with all this expertise. What certifications or licenses should we acquire to have a career as a data scientist? I have not heard of a specific data science licensure, or there are vendor-specific certifications that you can acquire, but it's not really a must to do that. It's learning, acquiring the skills, build your own GitHubs, my dear colleagues. Build your own GitHubs. That will be your portfolio. That will speak so much. That will speak louder than a really very glaring LinkedIn profile. No? So we do not have to be a math genius to be a data scientist. We just need to understand the fundamentals, the basics. All right. I appreciate those questions. No? So when we speak of data science, we cannot help it but look at machine learning. Machine learning is that actual phenomenon. There's a plethora of definitions across texts, across references. But just to make it simple, machine learning is actually letting the machine, the computer, our models, our deployed models in an app, our programs, our code, to learn some expertise. So say for computer vision, I am telling the machine to learn how I see. For computational linguistics or NLP, natural language processing, I am telling the machine, teaching and training the machine to answer questions that I ask, to summarize text, and all other use cases related to how I speak, to language, to translate one language to another. So machine learning is not really just about robots. It's us teaching the machine to do something, and sometimes, kaya nga siya artificial intelligence, this artificial entity, we are transferring intelligence to it. Sometimes it becomes even more intelligent than us, but not really. That's refutable. So the very first machine learning foretaste that we may have, and we might already ignore that it's actually machine learning, after all, is our good old emails. So when we open our email servers or email platforms, you see that your mails will be placed in the inbox folder and spam will be placed in the spam folder. But that machine learning app, that machine in that phenomenon still learns because, say, I receive Twitter notifications and it's been flooding my inbox already. So I don't want it to be in my inbox anymore. No, not Twitter, because Twitter is sometimes a valid, refutable again, a valid source of info, and for most, they want those. Say I visited the website and then I visited the website called ABC. And so I did a mistake and said I wanted to subscribe. And so every time that this website, this company's website, which is ABC, has some white paper, they throw them my way because I used my email to register and get something from that website. And so my inbox folder is already flooded. So when I see this email from ABC company, I click my mark as spam button. And so this machine learning deployment in my email filter will now learn a new characteristic, a new attribute, and the next occurrences of these mails which I have marked as spam, and trained my email filter that these kinds of emails are spam, will already go to my spam folder. But we now look at that as just part of normal life. It's just a norm more than something that's awesome or amazing. Something that will not even lead us to thinking about machine learning. You can see from this quote that this is fairly old. So machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. What does that mean? I don't need to program the computer and say, programming the computer in that example has an inbox and spam. Show every instance of what a spam is, taking a picture and telling my machine learning, my email filter, this is what a spam looks like. Every time I will do that. I don't need to explicitly program the machine. The machine will learn the attributes of this email that I don't want in my inbox, and it will go to my spam folder. And that's true for this slide also. So a computer program is said to learn from experience E with respect to some task T and some performance measure P if its performance on T as measured by P improves with experience E. I'm sorry about all these alphabets. So in a nutshell, what this is just trying to tell us, we need to train, we need to give that instance of an experience, we need to give that experience to the machine so the machine can learn from it. No? So that's what happens under the hood. You can say that that's what happens in machine learning and data science. So what is machine learning? We have different categories. So machine learning systems can be in this first category which would be supervised, unsupervised, semi-supervised, and reinforcement learning. They can be categorized into those four. So these categories would be qualified, would be dictated whether or not they are trained with human supervision. What is human supervision? We'll know that in a while. Then we also have online versus batch learning. This would mean this categorization would refer to whether our machine learning systems can learn incrementally on the fly, or they will have to do some batch learning, no? And then a third categorization would be whether machine learning systems are instance-based or model-based. Is that the type of learning that they do? And this category is dictated by if machine learning systems, whether they compare new data points with old data points, or they detect patterns. Okay, so we'll have 30 minutes before our 15-minute break. So this is what, but today we will focus on the basics of supervised learning and unsupervised learning. Maybe just I'll point you to some, I'll direct you to some further readings if you're interested about the other categorization. So what differentiates supervised learning from unsupervised learning? In the previous slide, it says that this type of categorization depends whether there is some kind of human supervision. And I made an air quotes when I read that. So human supervision in this context is what you see outlined in red. It's the why. Supervised learning has a human supervised target value, while unsupervised learning does not. That's a bit vague, no? Let's go to a specific detail. This, I specifically chose this online picture, this graphic, because I wanted to emphasize that the machine learns from a supervised intervention by humans. And what's that supervised machine? Supervised by human. What is that human supervision? What is that why? In supervised learning, our why is actually that which we are trying to predict. So say I'm trying to predict if it will rain today and if it will rain tomorrow or not, given the daily weather. No, given if it rained on Monday, on Tuesday, on Wednesday. So I want to predict if it will rain on Saturday and on Sunday. So I have some attributes here. Let's not look at these attributes muna. In this presentation, I will interchangeably call a variable, a column, and an attribute as also features. So I will use those four terms interchangeably. So our x's here are our, in statistics, we call them our independent variable. Some text would call them your candidate predictors. These are your columns, these are your attributes of a specific instance. In this webinar, when I say instance, I would be referring to an entity instance. If this was an entity, say student, entity instances would be student 1, student 2, student 3, student 4. So that's an instance. In machine learning, it's interchangeably called as a case, a row, an observation. Right? So those are the terms that you will use. So we said in supervised learning, there is some human supervision which some texts will call your ground truth. So say I have here different predictors or attributes, say a humidity reading for the day, say the lowest temperature, say the highest temperature of the day, and then a ground truth, an outcome, a label. Say this would be the readings for Monday, and it rained on Monday, so I will put here rain. This is my human supervision. This is my Y, my output. Say on Tuesday, I have this specific humidity reading, my lowest temperature recorded for the day, the highest temperature reading recorded for the day, and then it did not rain. So I will put here not rain. So this actually, dear colleagues, would be my Y. This is what the machine learning will use to learn what are the combinations, what are the values that depict a rain and a not rain. And I will learn that for all instances. So I will have like tens of thousands of data, and I will learn what values, what range of values would predict if it will rain, and what range of values for excess will predict that it will not rain. Hence, if my machine learning algorithm will learn that, I will now be able to predict my Y hat. Forgive the math, but we need to. So supervised learning is actually, this is just very quick, but we just need to appreciate it. Supervised learning is coming up with an estimator. It's coming up with your Y hat that approximates your Y. It's like, diba your Y, if you remember the equation of a line, no? Your f of x or your y is equal to mx plus b. So we're trying to approximate the function, the equation of the line, and our approximation is the y hat. Is some texts call it as an f hat, no, because it's a function. So what we're trying to do is actually math. We don't have to grasp and recall the math now, but what we're trying to do is actually come up with a mathematical solution, even if it's not apparent in this slide. Okay, no, so I will skip that math. So here, when I mentioned that machine learning or artificial intelligence will teach the machine, give it some intelligence that I have as human. So say in computer vision, look at this image below, colleagues. This is also one of the classics, no? This is a computer vision, a classification use case or problem where you have images and the machine or your model will classify if that image is an image of a puppy or a blueberry muffin. Now, for the naked eye, that would be easy, but teaching the machine to do that will take a lot. It's not hard anymore for the machine because our machine learning algorithms have become so sophisticated that the level of classification and attributes that it can learn and identify through computer vision is so sophisticated. Before, tasks were just to identify images, if classify an image, if it's a cat or a dog. Now, machine learning models are even to identify breed, age, health status of our pets. No? So these are really very crude as compared to state-of-the-art machine learning models now. Those who are interested, I hope you read this, but I'll not go into this anymore, so as not to scare a number. So I'll go to some use cases. I have another interesting insight in the Q&A, which I appreciate so much. So it's about social media platform learning. I'll just put that on mute. Put it in mute a while ago before I started. All right. So social media platform learning. What video to suggest based on the experience of how long you watch a certain video is an example of machine learning. Exactly, precisely. No, so these are falling under recommender systems. So the question is, when we watch videos in social media platforms, do these platforms learn or get attributes from our consumer behavior, us as social media consumers and users? No, so he said that, do they learn how long we watch a certain video? Yes, they get those. You know, people in with YouTube channels, like those that did some monetization. I think that's one of the currencies, like number of hours watched. Like if people just click and then exit, that does not really do them well. But if people stay from beginning to end, so how long you watch a video, that's learned. That's economy, that's commerce, that's already business, that's currency, that's money in social media platforms. But for us also, recommender systems, they look at your recommendations in YouTube, look at your recommendations in Facebook. The ads that you see are all reflective of who you are as a person. Unless you're really that good, that you're trying to, that your alter ego does not reflect who you are, your ads and your physical self will be incoherent. But you just be surprised, like, how well does the web know me? It knows me even more than I know myself. No, I have another insight or question here in the Q&A. Do you have to have a good grasp of computer programming to understand data science? Yes, we have to have a good grasp of computer programming related to machine learning, not all. So it's just really a niche, an area that you need to have fair foundations on, and you must be willing to learn for the rest of your lives. Now, people, this is so going to date me. Like when I graduated in college, dun pa lang nauso ang internet. So I tell you, I'm 50 years old. Wag na lang natin itago. So I'm 50 years old and yet I still learn programming. Suki pa rin ako ng Stack Overflow. Suki pa rin ako ng Kaggle and all online platforms. I watch LinkedIn Learning a lot if I have the chance, because I have access to it. So one must be willing to learn and not feel that you're too old or too tired to learn. Find your passion, be excited about something, and it's something that you look forward to and appreciate. So what programming language can we suggest for those who are new and wants to start a career as data scientists? I'll answer Python, but that's not a hard and fast rule. For now, I'll answer Python first, but towards the end of the webinar, I'll introduce to you the tools that I've been using and find your comfort zone. All right, so what's true for me might not be true for everyone, especially that I'm old school. especially that I'm old. No, you will be more sharp than I am. No? So let's continue with supervised machine learning use cases. So with supervised machine learning, if we have that human supervision, if we have that outcome, or we have that target variable, the target value, the rain or not rain, remember, we can do two tasks depending on the data type of that target value, of the target variable of that ground truth. Two use cases in supervised machine learning are classification and regression. Classification would be the one that you will do if your y, if that which you're trying to predict is a category. Say, for example, it will rain or not rain. That's a category. That's a categorical variable. So that's a classification task. You'll try to predict for our dear teachers who are in the audience. You're my favorite part of the audience, teachers, because you are teachers. So when I would like to predict if my student will say pass the subject or not pass the subject, that's a classification task because it's just two categories, pass or not pass. So that's a classification task. The second, supervised machine learning or supervised learning task is regression. If the y is a continuous variable would mean, and specific examples would be, say if I want to predict a specific grade that my student will earn, or say I want to predict the GPA of this student given his high school math and English math grades, and I want a specific value predicted. So that's regression. If I want to predict the actual temperature of the day given a year worth data, then temperature is a continuous value, that's regression. So those are the two tasks for classification, for supervised learning, classification and regression. And we'll look at classification here. You're not restricted to just having two categories, but in the event that you only have two, that's what is called a binary classification. As we know, binary would mean there would be just two values. So one is a positive and the other class is a negative. So say I have two dimensions, say height, x1, and weight is positive. I want to predict if this person, given his height, his or her height and weight, will be married or will be single. So let the cross or the knot here stand for married and circle stand for single. I know that that example does not really make sense, no? But those are the parameters we have. Our attributes, candidate predictors, independent variables, and that of our y, that which we are trying to predict. So I have here like 4 cases of, what did I say? A knot was married people. Their age would be at this, did I say age? No, I said height and weight. So they are the taller ones and the heavier ones. And then I have these 4 single people. They are not so tall and not so heavy. So say I have a point here, a triangle. I want to predict if this triangle is a knot or a circle, is married or single, given his height and weight. That is a binary classification task. We're not restricted to having just 2 classes or categories. Say for the use case where we'd like to predict a specific species, a specific leaf. So say we have this many images of leaves and given leaves a specific image, we'd like to automatically detect the species, that specific leaf, if it's Quercus infectoria sub, Quercus hispanica, Eucalyptus neglecta, etc., etc. You can see here we have 1, 2, 3, 4, 5 classes. So this is a multi-class classification. So those are examples of our classification use cases. Another example here before we go to our break. So yeah, let me just move this pane because it's hard for me to see. Okay, so there's also a question, by the way, is it hard to learn data science? It's not hard if you really like it. Like if you wake up in the morning and you look forward to it, ano ba ang gumigising sa'yo sa umaga? If your answer is data science, it's not hard at all. If you dread it because you need to learn it because my boss says I need to do data science work, then it will be hard. So it's really just a matter of motivation. But if it's doable. Like if a woman, a lady with 4 children who is approaching her 50 years of age was able to learn it, why can't you? No? Why can't you not learn it? So this is also an example of what do you think this is? Is this classification or regression if our target variable is bought a boat? So say there's this company who would like to profile customers because they want to market some more and push their boat sales higher. So they have this database of past customer profiles. So I have somebody of this age, etc., this attribute. So I have X1 age, X2 number of cars owned, X3 owns a house, X4 number of children, so on and so forth. Where my Y has bought a boat, because I want to predict if somebody will buy a boat given this attributes. So this, my dear colleagues, people in the audience, is as obvious, is a classification supervised learning task. There's one more here. So when you look at it, just by mere inspection, you can see, you will look at all the yeses, and you'll say that people older than 50 want to buy a boat, except for one instance here. There's somebody older than 50 who did not actually buy a boat. So this is what supervised machine learning will do. It will learn the cases. It might not be able to be correct for every instance, but it will learn the majority, the behavior of the majority. All right, so before we go on our break, last 2 questions. I want to create a portfolio that would showcase my skills in data science. That would be great. You start today. What projects would you suggest that I include in it? Currently located in a private university as a support staff and visiting lecturer. Thank you. So possible projects, the first one would be, what data do you have access to? And when you have access to this data, you have permissions to publish the data. Is it not confidential? Pero the second question, you can do something about it. You can anonymize, you can deal with data with strict confidentiality. The first question lang talaga is, what data do you have access to? Second, if you want to do a project that's related or will benefit your institution, look at and go back to the boardroom, meaning go back to your institution's strategic goals. What are its vision and mission? Institution ako. Tapos, ang goal, ang vision and mission ng company I would like to prioritize employee productivity more than savings. Pero ang project ko, I highlighted savings a lot, sacrificing, giving tools to my employees such that they are productive. Maganda nga ang findings ng aking machine learning data science project, but it's not really aligned to the goal of my institution. That's something that you have to consider. And last Q&A before we go our break is classification and regression, somehow similar relative to multi-dimension array in Java. That's a good initial observation because it has something to do really with multi-dimensionality. Thanks, Miss Dana, again. So we are back, everyone. And let me just go back to our slide deck. There. So as a review again, what are the two categories of machine learning? So first is supervised, which has that Y, which we call as our target attribute, our class, or something that we want to predict. That's our human supervision. That's our ground truth. So the goal is to discover patterns in the data that relate data attributes with that specific target attribute. So in essence, we're trying to predict by either classifying or regressing. No? And then now we go to the unsupervised machine learning or unsupervised learning. This time we said that unsupervised learning does not have a Y. So meaning the use case for unsupervised learning is not prediction because we're not predicting something. And we don't have a Y, we only have our X's. Ibang klaseng X na independent variable, hindi yung X na gusto na nating kalimutan, no? So unsupervised learning is when you'd like to find some intrinsic structures in the data, the relationships that govern this X's, what is happening, how do they react, do they cluster together, are they associated with each other? Those are the questions we ask with unsupervised machine learning. And so unsupervised learning or machine learning, you can omit machine. So unsupervised learning goal is to use the variable values to identify relationships between the observations. Qualitative assessments, such as how well the results match expert judgment, are used to assess our unsupervised learning methods. So after we do this computational approach, after we do this machine learning, we do some qualitative assessments for maybe looking at internal, external validity or some construct validity, or does it make sense? So, or did it achieve the goal that we have, the task at hand? So let's now look at specific unsupervised machine learning use cases. So this is the specific clip I chose because this time the machine learns on its own without that Y, without that human supervision, without that target variable. So one particular use case, a very famous use case for unsupervised learning is cluster analysis. As the name implies, we are looking for clusters within the data. So the goal of cluster analysis is to segment observations into similar subgroups, into similar groups based on the observed variables, based on the X's. So clustering can be employed during a data preparation step to identify variables or observations that can be aggregated or removed from consideration. So Sometimes cluster analysis is used prior to the supervised learning approach because the clusters will then be used as a target variable or sometimes another feature. So it can be a preparation step, but cluster analysis is a valid analysis on its own. It can answer many interesting questions across domains, across industries. It can also be used to identify outliers. Sometimes when we do most of our statistical goals, what we do with outliers, we remove them. Try to imagine a two-dimensional space, your x-axis and your y-axis. And then you have your points. And if you're trying to approximate the behavior, or in math, you're trying to fit a line by computing, adjusting a line, coming up with a line that will represent the entity, all the entity instances behavior, the outlier will skew that line. Kasi mahila, what will an outlier do? Say for example, sa mga board exam results in educational institutions, like if somebody scored really low, that will pull down the institution's parang national performance. So that outlier sometimes or most of the time hurts the data. Even if the score is really high, such that in real life, it's a bonus, it's a good thing, there's an outlier, it pulled up the performance of the majority, but it hurts the analysis. Why? Because it does not anymore predict a real picture of what is the norm. No, because these are outliers. This will skew, this will pull your data. Imagine when you're trying to compute an average of all fives, you get 5, nearer to everyone. Say you want to compute an average of all fives and then biglang may nag-99. You will have a high average, pero that's just 1 point lang pala. One value na 99. So cluster analysis will be able to identify these outliers and treat them as how we'd want to treat them later on. No? So let us try and look at cluster analysis. We have 2 methods, hierarchical clustering and k-means clustering. For tech people in the audience, these are 2 categories of algorithms that you can approach clustering with. Hierarchical would be bottom up. So, i-group together muna niya ang mga points that are similar and then have these small subgroups. Then go a layer up, i-group together naman ang subgroups that are similar, move another layer until you come up with a cohesive, just one cluster representing all the subgroups, eventually representing all the points. K-means would be top-bottom. Initially, you would have a preconceived notion of how many clusters do I want. For our beloved teachers in the classroom, what is a specific use case? Say, I have to render consultation hours, and I have only 5 available time slots for consultations. And say I have about 1,000 students. So I want to group my students into 5 such that because I only have 5 available time slots anyway, I cannot afford a 6th time slot. So I will tell my students, group yourselves into 5, or I will do cluster analysis. I will come up with attributes, say, group my students in an automated fashion, just run any cluster analysis tool. Now, group together the students in terms of academic performance. Or, so come up with 5 groups, na using academic performance attributes or group together group together students na same academic performance so that I'd be able to have homogeneous groupings. Kasi gusto ko homogeneous. But what if I want like more a peer-directed learning such that those who fare really well will mentor or peer those who do not fare as much as well as those who do. So I would like heterogeneous grouping. I can also specify that in my attributes, in my criteria for cluster analysis. So sometimes I can even group students according to, say, geographical locations. Those who live near campus, those who live far from campus. So for some other reason that only I will know. So that's the reasoning behind doing k-means clustering. You have an arbitrary number in mind to find specific groupings in your data set to respond to a specific domain goal. So say, or constraint. This is an example for a business setting naman. I'll not go to the distance computation. So say we have a fictitious company called KTC. KTC is a financial advising company. It provides personalized financial advice to its clients. So I'd like to underscore the word personalized. Personalized because yun yung come-on niya na it will, depending on the profile of the client, I will give you a financial advice or portfolio that would be fit given your profile. The thing is, if I have like 5,000 customers or clients, it will be very costly for me, KTC, to come up with 5,000 personalized portfolios. That would be taxing my resources, my budget for ads and promo, my budget for whatever kind of support to push these portfolios. So what I would do, I'd like to segment my customers into several groups or clusters so that the customers within a group are similar or dissimilar with respect to key characteristics or attributes. So that is one use case. Now say we have this specific client. I used a different set of letters here. It's KTC, now it's ABC, but it's a fictitious company anyway. So we have this characteristics or attributes, the age, the gender, the income, marital status, number of children, presence of car loan, presence of mortgage. So you have this vector of numbers representing that single point, which corresponds to a 61-year-old male. So we have here some nominal representations. No, 0 would be male, 1 would be female. When we have nominal representations as a side bit, it means that these are just numbers do not reflect the magnitude. Numbers do not reflect are not used for computation in layman's terms. So male being a 0 and 1 being a female, it doesn't mean because 1 is greater than 0, female would be greater than male, but it might be true in a sense. No, I'm just kidding. So we have also the third value, income. So this 61-year-old male earns 57,881 annual income. He is married. So we could like infer that 1 is a nominal value representing married for marital status. And then this is the number of children. This is a nominal value, possibly binary values ito na variable. 0 without car loan, 1 with car loan. Then we have 0 paying a mortgage or 1 not paying a house mortgage. So this is how clustering is done. What clustering will do, colleagues, is that because we have this vector of numbers, it will be very easy for clustering because it will just compute the distance between these points. When you compute the distance, you just like subtract, diba? So a distance would be the construct that would pertain to if 2 points are similar. So you'd imagine a 61-year-old male and a 60-year-old male would not be that far from each other in the dimension of age. Because if you compute the distance, deduct 61 minus 60, 1 lang, 1 unit lang ang difference. So malapit lang sila as opposed to an 18-year-old male which would be farther from the 61 and the 60. So that's how clustering is done. So it's really fairly easy to imagine, right? So I'd be able to see clusters of these groupings based on the attributes. We'll have a specific example using R, a scripting language, and RStudio this afternoon. So watch out for that example. In fact, we have 2 examples for clustering using R as a tool. And there'd be some visualization, so you'd appreciate this more. But for now, this is the use case where clustering is applicable. So now we can think of many things to apply clustering to. Like, say for example, I want to see how many, say I'm a business owner. Gusto kong magtayo ng salon. But I want to find that specific location where I'd have competitive advantage. So, di ba, if we recall, our business professionals in the audience, they call the classic Michael Porter's competitive advantage or framework. You look at your competitors, your suppliers, your consumers, so you look at them where they are in the map. Or map your cluster, your competitors. Pag nakita mo na this area is already a cluster of these competitors, you'd say that this is already saturated. You'll find where the clusterings are, or maybe this cluster has salons na ang target market would be middle class. This one is for the high end. Ang gusto ko, middle class. Should I join this or should I join this cluster? So, dito ako sa cluster. Or, kung gusto ko to diversify para may choices naman yung mga high-end, yung mga middle class na gusto sa high-end communities, I will go to this cluster. So, this would really give value added to actual decisions in organizations, in business, in institutions. You are creating data-driven, you are creating opportunities for data-driven decisions for your institutions. Isn't that exciting or exciting? No? So let's, so this is something that we will execute and do later, but I placed a screenshot so you'd appreciate it here at this phase. So say you have the points here would be the clients of KTC, which I also called ABC company, that financial advising company that provides personalized financial advice portfolios to its clients. So it saw that if it used K is equal to 2, meaning if it identified 2 clusters, it find these 2 well-separated clusters. If it wanted to create 3, we have 3 clusters here. Pero when it reached 4, even 5, it's already problematic. Why? As with all clustering analysis, kahit hindi kay KTC. If you already see overlaps here, then they're not anymore, especially C5, or you would see the green, the second cluster is already inside the fourth cluster. So the goal with cluster analysis is to come up with well-separated yet cohesive clusters. So ang measures for our tech people in the audience, our dear students doing their quizzes, and incidentally, you're doing cluster analysis work. What's our measure of performance for cluster models? It will be within cluster distances. Dapat maliliit ang distances para similar talaga sila. And the second measure of performance is between cluster distances. Between cluster distance should be malayo para distinct, justified talaga na this is a distinct group, this is a distinct group, they're different clusters, right? So that's cluster analysis for us, one of the more popular and go-to methods for answering, for doing unsupervised machine learning. Second is association rule mining. So who says mining is bad? No, we have association rule mining. Association rule mining, if we go under the hood, we are just really deriving if and then statements. But if you want to laymanize this approach, this definition, association rule mining, association rule tuloy. Did I put rule? It's rule. That's a misspelling because it's rules. Association rule mining is really finding rules that pertain to how the attributes are related to each other across the observations. And to make that more clear, let's do an example. Say, for example, di ba we have our frequent shopper cards where every time we buy, we give out our consumer buying behavior, our purchasing patterns to stores in exchange of points. And what will they do with that? So every single transaction, they keep it in their data warehouses, in their data lakes. One use, a classic use for this and for our business professionals in the audience is, as you might have guessed, is market basket analysis. Market basket analysis is really association rule mining under the hood, or when we use the lenses of machine learning. If we use a separate lens, which would be the lens of business intelligence, or those in the business industries, they would call it market basket analysis. Because why do they call it market basket analysis? I feel the term is really appropriate and cool. Why? When you look at the market basket, you would try to look at what products are in it. Because in essence, association rule mining will find what items frequently occur together. Sus, kahaba-haba pa ng definition sa previous slide. Yun lang pala yun. What items occur together? Yes, it's what items are occurring together. What items will you find in a market basket? So say for example, it's kind of easy when we look at this slide, but imagine how many times, how many people, lalo na that Jose Marichan is out now, like Christmas spirit is just by the corner, and then we can go to our favorite supermarkets. How many people are there? How many buying patterns? How many market basket data do we have? So here we'll find na, say for example, say what patterns do we find here? Like Jelly and soda, when they are together, there's milk. Oh, not always, kasi si number 4 does not have milk but have jelly and soda. Jelly and soda with milk. Jelly and soda, no milk. Jelly and soda, jelly soda, milk, milk. So that's what it will do under the hood. That's what the algorithm will do. Technical audience, you will computationally do this, and the metrics that you'll use would be confidence and lift ratios. So for our dear students working on their thesis, incidentally using association rule mining, you would probably have known that your performance measures for association rule mining models would be confidence and lift measures, not to derive the rules. But for us, who will consume, who will use the insights derived from market basket analysis, what insights will this give me? So say ako, I am a small scale business owner. I own a small shop selling groceries. And I would like that when people go in my small grocery shop, they buy and then they go out so that others can come in, because the longer they stay there, masikip, it will like drive away those who want to purchase. So if I found out from my association rule mining that jelly and soda are bought together with milk, what I'll do is in my shelves, I will put the shelves where jelly and soda and milk is. Pero if my goal is to suggest or push slow-moving items, I will put jelly on the one end, soda on the one end, milk on the farthest end. Why? Para sigurado ako that my clients who will buy jelly will pass by other lanes where I can suggest my promo, my slow-moving products, and it might entice them to pick something up on their way to get soda, and then on their way to get milk. So you see how machine learning can help us make the right decisions aligned to very specific organizational goals. Yes, that's also correct. Somebody in the Q&A said complementary goods can also be packaged together. It can also give us an idea on which items are complementary, which items are I don't know the term, but yeah, you can like sell them together. Possibly a substitute? No, but a substitute cannot. They're complementary. Yeah, that's the proper term. Thank you for bringing that up. And yes, I appreciate, Ms. Aktub, salamat po. It's an upselling strategy. That's appreciated. So you see how data science and unsupervised machine learning can push for upsell strategies. Hindi lang na-rely on experts, historical opinion na feel ko ganito. Why? Gut feel ko lang. I've been in this business for so long. That's how I knew it. And then it's not even backed by data anymore. So that's unsupervised learning. Do we have questions with unsupervised learning? All right, so if we don't, wait. So I just like to mention that even here in Walmart, transactional data is also used to uncover strong evidence of association rules. So like if customers purchase a Barbie doll, then customer also purchases a candy bar. So it will, what I'd like to highlight is the third, pangatlo ba to? Third, second, basta it's the last bullet point. an association rule will only give added value to an institution if it will reveal a previously unknown rule or unknown relationship. It's of no added value if we say, boss, cigarettes and lighter are bought together. Oh, okay. What elegant machine learning algorithm did you run to find that out? So association rules will be appreciated when we have these surprising relationships, and be surprised at the surprises you'll get when we use machine learning to discover these relationships. Okay. So later in the afternoon, I'll be using a tool that does not require programming. You can download it. It's an open source tool, a fairly classical tool. It's called, which did I use for my demo for a priori? It's called Weka. So I'll also highlight Weka this afternoon as one of the tools, and we will do a priori algorithm. We'll discover some rules and first we'll generate the data and then discover some rules, implement a priori algorithm in less than 5 minutes. In a snap of a finger, you'll be able to implement that. Okay, so I'm excited. So we have a few questions. I appreciate the questions. Very active naman ito si Sir. Does this mean that if we provide the right data to the machine, we provide the accurate human experience, it can really find the match for us? Correct. The same way with online dating sites. Yes, that's accurate. That's a good observation. So, but sometimes people, like before, nung kakaumpisa pa lang, nung kapanahunan namin, we do not reveal ourselves online. Look at our old email addresses. It does not have our names, maybe a call sign, but our names are not revealed. And then we were so worried about the confidentiality about who we are. We are, lalo na in the Philippines, we have a different alter ego online. But things have evolved. Now the modern citizen, this digital citizen, kung sino siya in real life, sometimes mas nilalabas pa niya ang vulnerabilities niya online. No, like we speak our thoughts in Twitter, we rant on Twitter, we dance like we have now audience in TikTok. So we give too much of ourselves online, and so related to the point that we provide accurate human experience and data to apps, to the machines, they get a fairly accurate grasp of who we are. So we get ad recommendations. If we are on meeting new acquaintance online, so we get new acquaintance whose profiles match our profiles. So yeah, that's a valid point. I appreciate that point, Mr. Martinez. So do you have any book recommendations to read related to data science? I have a lot, and I will show them in the afternoon session. Book recommendations that we don't have to purchase anymore. A lot are from MIT. So they have books that they provide, online resources that they provide. Watch out for those in the afternoon session. If I will work in data science, what computer course will I enroll first? You can enroll and study Python. Now, you can also like go back and refresh take a refresher course on statistics. You can also study databases, no, because data and databases, those are the courses that will help you jumpstart a career in data science. So, okay. So, but I have just recently been doing like hardcore, like data science and data analytics work just starting 2019. I've been doing it part-time when I was studying my PhD because of some collaborators in the lab where I was connected with. But for like doing it 24/7, I've just started it in 2019. So when I started, I just knew Python. I knew a few data sciencey packages and approaches, but I really tried to learn. So I learned as dictated by the task at hand. So what I wanted to do, questions I wanted to ask, I learned them gradually. So I did not have a formal, devoted data science curriculum. But again, as we have appreciated early this morning, data science, after all, is anchored in computer science, in statistics, in math, and the domain expertise. If you want, so we have another question here that if you want to be, I want to be a data scientist in the future, what entry-level job should I aim for? Data analyst, software engineer, etc. You can start being a data analyst. It would not hurt if you also have some software engineering expertise, because data science jobs now, they are, you deploy them. So most especially if you'd like to work with, say, Meta, which is Facebook now, Meta or Amazon, you will start from data wrangling, data collection, up until deployment when you will actually implement your models. So a full suite of skills would be good. But yeah, you're right. Data analyst would, I guess, be my first tier, kumbaga, in that data science ladder. So yeah, that's a valid insight. Okay, so do we have other questions? So what we have next would be data science trends. Maybe I would start them now, or do you have questions? So we'll entertain questions. What's the difference between search engine optimization and data analysis, or are they related? That's a very valid question, ma'am. When you feel, I feel that you've hinted some relation. That's why this question. Yes, search engine optimization uses under the hood a lot of machine learning and data science and data analytics. It uses data analytics in a way that it will point to the right machine learning algorithms to find, say, we'll see that in one of the demos this afternoon, like a similarity between a search key and the actual web content or digitally curated content on the internet. So you will find, say I have a search key like the National Cybersecurity Plan. So I will find documents or resources that are available on the net, possibly to point me to of course, the DICT website. It will point me to some websites mentioning or discussing this search keywords that I have been looking for. So yeah, they are related. SEO is a specific use case or function or purpose where there's some data analysis methods that equip it, and machine learning and data science models that enhance and give more optimal results to SEO engines. That's a good question. Is Google Access a good, reliable tool for data analysis? Yes, we have a lot of tools for data analysis. You have your for analytics, yeah. So Google has one. We have also some tools that I will also present later. That would be Tableau and Power BI, but I will dive into tomorrow when we go to Google Analytics. Google Analytics, I was reading when we go into data analytics. So yeah, that's yes, it's a reliable tool. These are valid tools that we can use. Open source tools for data analytics, as you will also see tomorrow, when we don't have access to these elegant proprietary tools, there are open source tools, but that we can use. No, I'll feature them also in a while. But there are also some proprietary tools that have some free version that we can use. So that's those I'd also recommend. Plus, good old Microsoft Excel can really crunch out data analytics results that are comparable to proprietary, to more focused tools. Yes, trends is also popular. Yes, ma'am, that's accurate. Okay, so we have those. So how about I start with data science trends. Let me stop sharing for a while. So I would open our, we did go fast. I think I went a bit fast. I'm going to slide deck 3. So we have 4 slide decks, but the 4th one is pretty short because I'll be in and out using the tools that I've highlighted in the 4th slide deck. So now here we have our 3rd. Okay, and then I will share my screen again. There. So we have appreciated, share slideshow is taking quite a while. There. We have appreciated already 2 categories, the basics of data science, 2 machine learning systems, methods, approaches, which are supervised learning and unsupervised learning. Now, when we speak of data science trends, because we are here to future-proof ourselves anyway. So we should look at the trends of where things are going. We will always encounter deep learning. So I have a resource for deep learning that's I didn't share my entire screen, just the presentation. So let me share the entire screen instead, because it opened a website. So the link in the first slide and deep learning, this is Python notebook in Google Colab. So when you're starting out your data science careers and experiments, or just doing mini data science projects for your institutions, just to explore or to learn a thing or two, I suggest that you use Google Colab. So all you need is your valid Google accounts, and it will give you this environment, which is Google Colab. So you can create your own notebooks, no? And you can run it cell by cell. We'll have a demo of this towards the second part of the webinar in the afternoon, because we'll try some use cases, some really fun and interesting applications of data science in the afternoon. So this is a Google Colab notebook on deep learning basics. And this is one of the resources that I would recommend. And as if you can see, this is a tutorial. It has a lecture on the basics of deep learning. It's from MIT. So let's close this tab so that you'll be able to view it. What's happening to my screen? Okay. So what's good with Google Colab, by the way, I forgot to mention, is that there's a runtime here. You can have you can work with Python 3 and R in Google Colab. You just shift the runtime to support your R codes. But what I will demo later in the afternoon, I will run R in a different tool, its own, it's a native tool for R, and a popular IDE, or integrated development environment, or a platform for coding R. So but you can do that in Colab too. So what's the upside of working on Colab? You have runtimes. You don't have to have local installations and configurations for Python, Anaconda, Jupyter environments, and the works for R and R Studio. You can just have them on the cloud, no? Your development platform on the cloud. What's a good thing too is that Google allows you to use GPU resources. So if you have some deep learning that you will do, but for some limited hours only. Now, when we do actual data science work, dear colleagues, sometimes I would like run my models for days. And then that's how computing resource intensive the work is, most especially if you have like volumes of data. And in my work, I work with text discourse data. So you'd imagine the volume of data that I have. So that's why my work is so computing resource hungry or intensive. So let's go back to this slide, and this is our deep learning basics. And then you'll have here also examples of deep learning, but categorized in supervised learning, which we have appreciated already earlier. We know what that is. Supervised learning, again, you have a y, a variable y. You have something that you will be predicting. You have your ground truth. You have your human supervision variable. Unsupervised learning, you don't have that y, but you only have your attributes, and you'd find inherent characteristics and relationships between these attributes and the observations. So deep learning is also a method, a whole suite of methods that you can use in supervised learning use cases and in unsupervised learning use cases. So examples would be, I know this is a lot and don't get overwhelmed, but it's just nice to have some sort of recall when we read about it, when we hear this thing. So I know these terms are already familiar with most of you, their colleagues, and even to you, our dear students. No? So we have feed-forward neural networks, you have convolutional neural networks, you have your recurrent neural networks, or our RNNs. We have encoder-decoder architectures. If you see the word transformers now, they are encoder-decoder architectures. It's transformers used to be just these robots, no? Sila Bumblebee and Optimus Prime, but for us nerds and geeks and data science, when we speak of transformers, we don't think of them but encoder-decoder architectures in deep learning. So we also have autoencoders, GANs, generative adversarial networks, also those used for reinforcement learning. But word of caution, do not dive into deep learning if you have not understood the basics of or the workings underneath artificial neural networks yet, because they are ANNs with some complexity, with some flavor, deep learning architectures. So this slide set has an example, which is one of the popular use cases, a classic use case in data science, which is image recognition. More particularly, specifically, handwritten digits recognition. So to the naked eye, again, it would be a breeze for us to understand, given a number, kahit paano pa man isulat ang number 5, makanto man o makurve man, or para man siyang ahas, we'd still recognize it as a number 5. But that's a different thing when you want to teach the machine, when you want the machine to learn that, because it will look at the contours, the shape, the edges. Now, if a 5 would be written like 8 different ways to point to that specific number as a 5, that would be difficult for the machine, but doable. In fact, now that's easy peasy for deep learning models. No? So if you will look at this notebook, when you get the slide set, again, this link is on the first slide in slide deck number 3. So when you look at that if you check this out, for those who'd like to dive into the technicalities of deep learning, the tutorials here are very conducive, no, to learning it, to very easy to understand. No? So I'll just go to, so libraries packages are TensorFlow and Keras. Those will be your staples when you do machine learning. But I'll go down immediately to the part na there's this kind of an animation of how this works. So like say this is the number 5, the neural network will see from all the possible cases of what this number, this image will be classified to. You'd see that this image being a 0 will only render 1% confidence or probability, or confidence to be more exact. This being a 1 is still 1%, 2 1%, up to 4 1%. Everything else is 1% except a 5. It's so dark, I can barely see it. It's 91% confidence a 5. So you'd see that how it will find the most likely predicted case for an image. Now, underlying this seemingly very trivial task, an image, you will have to translate it bit per bit, pixel per pixel, and provide those vector of numbers and the different combinations of how a 5 is written to your model so that it be able to detect what the actual number written in that image is. That's how complex it is. It's not as trivial as this because we're using our own eyes. So this is the animation that I'd like you to see. Try and observe. Look at the sample inputs here. It's not always 100% confidence. You can see some 65, some 72. It just runs so easy, no? A 7, an 84, sometimes 100. So you can observe that while I answer the question. What will happen if the learning rate is set too low or too high? Again, I thought that you were my student. That's a question that I always receive from my students. So as a backgrounder, we, when we do deep learning, we do some hyperparameter tuning. What is hyperparameter tuning? Hyperparameter tuning in deep learning would be finding the most optimal parameters such that we'd be able to get our highest model performance. If our model was a regression model and not a deep learning model, yung parameter ng regression, say ng linear regression, would be the weights. Example, no? What would a linear regression look like? Diba? We go back to our equation of a line. Y is equal to, say, alpha x1 plus alpha x2 plus b, some constants, some intercept. Alpha is the weight by which x1 contributes to the prediction. Alpha 2 is the weight of x2 by which it contributes to the prediction. Hence, for a linear regression model, the parameters that you want to get and have optimal values of would be alpha. Okay? But for a deep learning model, one of the parameters that you will need to set, and some other models is a learning rate. Now, learning rate can be set too low or set too high. For this question specifically, we should find that right spot that will, if we set it too low, we will not be able to learn as much. We will not be able to predict unseen instances. We might do well with our training data. Forgive the technicality, a deep dive, because this is a technical question. So just like enjoy the clip. for those who don't want to dive into the technicalities. So going back to the learning rate, if you've set it too low, we will be, we might not be able to predict unseen instances properly, as accurately as we are predicting the training data or the validation data, the data that we have. If you set it too high, we might just make our model too complex. It will take forever to train the model because it's too complex already. So we must find the sweet spot. It's the same as finding that sweet spot of the bias and variance trade-off. Learning rate will also be connected to that. I'm happy to take this technical question offline if you need some, like on the side, details, juicy details on setting learning rates. But that's a good question. I welcome the insight and the question. I hope I answered it. So as you can see, deep learning has its use cases mostly on computer vision, image recognition, how do we call this? Forensics and handwriting forensics or something. Basta image recognition and computer vision use cases almost always are implemented using deep learning algorithms and models. And if you want to dive into deep learning, this is a good starting point, this notebook. And MIT has a plethora of resources for deep learning. Deep learning for the institution, it's doable, but there is some level of mistrust on deep learning models for non-computer science, non-computing institutions, because deep learning somehow is a black box. You give it the data, you give it input, it will give very high accuracy predictions. That's a given. But you cannot explain what contributed to those predictions. That's the downside of deep learning. But now there's explainable AI or XAI, another trend that you can arm yourselves with, that you can, data scientists, budding data scientists in the audience, future-proof yourselves with. Aside from being able to create sophisticated deep learning models, you're now able to interpret this black box using XAI or explainable AI. We also have a couple of Python packages for explainable AI. We also have explainable AI support in data mining, data science tools that are non-programming, which I'll show later. So I will not continue with the data science trends anymore. I'll resume that later. I'll devote the rest of the few minutes we have for questions, if there are. Hello, Ms. Dana. Good afternoon. So good afternoon again, everybody. Let's continue from where we left off. So this morning we started looking at trends. We will continue that same slide deck for the first part this afternoon, and then after we'd get our hands dirty and look at the tools. I had to change venue, so you might have noticed the different background. So I'll share my screen again and go back to the trends. So again, we have deep learning as a trend that you can look at. So for students who would like to find thesis topics. There's still much to improve on for deep learning. When we look for thesis topics, we are looking at points of improvement where we can, if not surpass, at least live up to the state of the art. And so with deep learning, you can go on ahead and address its limitation through what is called XAI, or explainable AI. It's not really new or unexplored, but there's still some novelty for explainable AI. So for the next set of trends, we will look at specific subfields of data science. And the next one is closer to my heart because it's what I'm actually doing. It's primarily my job function here in Arizona State. And although I do non-qualitative data and do quantitative analysis using data science techniques, most of my work would be on natural language processing. So what is natural language processing? So it's using computers to analyze the spoken language, no? Not only spoken, but different types of corpora that would reflect man's communication, discourse. So this would be guided by theories, models, and algorithms. So natural language processing is still, if you go to that visualization we had earlier, where we have statistics, yes, we still have statistics and calculus, very much of that. We still have those. We also have our algorithms, our computer science body of knowledge. But on the domain expertise, we have linguistics, anthropology also, as we look at culture, and some other related theories. We also have psychology as we look at what happens in the mind, what is the cognitive and metacognitive constructs related to how language is produced, how language is consumed. So that's what we do with natural language processing. And a specific goal is to calculate linguistic indices that move beyond the surface level tasks to derive insights relevant within educational context. That's the NLP analysis goal that I do here in my work. But NLP does not have to stick to educational contexts. It can have anthropological, cultural context. It can have psychological context and other areas that we can relate to language. After all, language is a medium that we use in all aspects of life. So it's not surprising that we'll find natural language processing across many contexts. So let's look at some nuances when it comes to NLP. We also do a bit, our lab also does computational linguistics, and sometimes they overlap, but purists tend to disagree. Some would think that computational linguistics is a distinct field that's very much apart from natural language processing and vice versa. I would belong to that school of thought where they overlap more than they being distinct, because the methods that I use in my NLP work would also be the same methods that I use in computational linguistics. So let us go through some of these statements. These are excerpts from a computer science professor. So there might be some bias on this discussion because it uses the lenses of somebody in the computational field. Purists on the linguistic side might not feel the same way, might not echo this same sentiments. So first in this blue box, it says, so this is Professor Jason Eisner from Johns Hopkins. He said that he uses these terms to indicate different research goals. So the methodologies are often related and the communities overlap. We go to the same conferences and easily talk together about our problems and solutions. So this is where I'm coming from when I say that I feel that NLP and computational linguistics really do overlap because the methods, the algorithms, the artifacts that I produce at work would be similar. So we go to the computational linguistics quote here or excerpt, and it says that computational linguistics is analogous to computational biology, computational something else, or any other computational fill in the blank. It develops computational methods to answer the scientific questions of linguistics. So for the general audience that we have, in your field, you can very much attach computational in front of your field and come up with a distinct field that you can apply data science to. So say you'd like to name a specific unit, propose a specific unit that will have, which will be mandated to do value-added data-driven analysis to support critical organizational decisions. You can name that unit as computational something. You can do computational human resource development, or you can do computational front office support. So we can put basically any term after computational, and it will signal some data science-y approach that is anchored to a specific goal or task in an organization. Now we go to the yellow or mustard-like color, which is an excerpt on what his view of natural language processing is. So it says it's the art of solving engineering problems that need to analyze natural language text. Yes, that's the corpus that we have. That's our data set. It's not as structured as what we have seen earlier because it's free flowing. It's discourse. It comes in different forms, shapes, and sizes. Here, let me continue. Here, the metric of success is not whether you designed a better scientific theory. Rather, the metric is whether you got good solutions on the engineering problem. So just going back to our rationale this morning, we will always anchor our findings, we will always anchor our efforts, our data science efforts to and align it with the goals of our institutions, no? So that our findings will contribute to the achievement of these goals. So data science, in our perspective, most especially today, as we gather together coming from different fields and backgrounds, but representing our institutions, our own specific set of expertise, we agree that data science is an armor to future-proof each of our own institutions. It will also future-proof our own professions, our own careers. So we are packaging our future self to live in that future world, in the fifth IR world. So this is a good description looking at the nuances of computational linguistics and NLP, again, there's this bias because this is somebody from the computer science field. We may have linguistics experts in the audience who might not feel the same or agree to, but you may also agree to this points of view. So what are use cases of NLP in daily life? Let us look at again what we have in our hands, no, in the app. So have you ever visited a website where suddenly just when you log in, there would pop up at the bottom like a conversational chat bot that guides you through the use of the website or asks what you will need, what assistance you may need. So this would be chatbots and virtual assistant. A classic NLP use case is also language translation. No? So we have, of course, Google Translate for that, and other apps that we have to translate one language to another. Then we also have text-to-speech and speech-to-text apps. They also have NLP models embedded in them. No? So aside from the text-to-speech and speech-to-text engines. So these are just a few use cases in NLP. In a while, in part 4 of the webinar, we will have a demo of interesting NLP use cases, and I'll use Python packages for that. Don't worry, we'll not do some technical programming. I'll just introduce the environment and the packages that are used. We'll just appreciate the outputs of how it is applied. For the technical audience, that will also, what your takeaway from that demo would be the packages that you will use, the state-of-the-art models that are made available to us, data scientists, that we can tap, no, and use. So these two interesting use cases that I'll demo would be under deep NLP. If a while ago, before we took our lunch break, sorry about that, before we took our lunch break, we were introduced to the concept of deep learning. And we said that deep learning is really anchored on artificial neural networks with hidden layers. For our techies in the audience, deep learning is a trend, not really the newest trend, but there's still much action for creating new models of state-of-the-art, no? So deep learning and NLP has also permitted NLP, and so we call this deep NLP. And what I'll demo would be deep NLP examples. So first, we have, this is Bert from Sesame Street. I know that there's a newer version of Sesame Street, but when we were younger, so you'd imagine that was like decades ago, we'd be watching Sesame Street on TV. So we have this Ernie and Bert. That's why you have that image there. But Bert is really a deep learning, a state-of-the-art package and model in NLP that is used for a wide variety of use cases. So one that I can think of would be summarization. So for my favorite for my favorite teachers in the audience, like when we record or maybe grade summaries that students will submit, imagine when you provide a text to a deep NLP model, and generative NLP is able to generate summaries from the text. So imagine the task of summarization is already automated. So it will automate summarization aside from the classic topic modeling, where it will extract topics and keywords from texts. So these are what NLP practitioners do, and BERT is one of the more popular go-to tools for doing these use cases. Another would be question answering models. So we will do this in a while in the second part of the webinar. So with question answering models, like if you have an automated bot, say in a website, and my website, say, is about my company. And so I will have clients who will visit my website, and I will deploy a question answering model such that when clients will ask questions about any of my products or any transactions that they can do with my company, that bot will be able to generate coherent answers from the sources that I have made available. The demo that I prepared is I pulled up from the DICT website the National Cybersecurity Plan, I think, if I'm not mistaken. Kung hindi ako nagsi-senior moment. So I pulled up that document, and then we will try asking questions and let the deep learning model answer those questions and finding the answers from the document. So how sophisticated is this compared to previous implementations of question answering? Previously, question answering implementations would be so crude, such that there would be a canned collection, so ready-made ba na questions and then matching answers. So it's like a string matching task under the hood. There's this question, I will find that question in my pool of questions, then there's already statement or answer, and that's how question answering is implemented ages ago. But with NLP and deep NLP, question answering models are now sophisticated such that you just give it a source text, it's now able to answer any type of question. So say I have a source text that's about, say, Harry Potter. If the question I'll give would be, who is that giant who loves dragons, then the model will answer, the giant is Hagrid. If somebody asks, what's the name of that giant? And so the question answering model is able to find that also. Kasi kahit magkaiba ang structure ng question, the question answering model is already, the state of the art is already so sophisticated that it is able to extract the intent of the question and find the answer, if it exists, in the source document. So that's what we will do, no, for the demo. So aren't you excited? So I'm excited to show that too. I wish that I put in Harry Potter instead, no? Anyway, I'm an old Harry Potter fan. So another use case with deep NLP, with state-of-the-art deep NLP models now, that what they can do is semantic similarity. Ms. Marge has asked us earlier about SEO. That underlying that is also some semantic similarity model. As we said, I will search for matching documents given a search keyword or keywords. And what it used to be, a previous implementation used to be just looking at keyword matches. Now Google implements sentence level matches such that why? Because it intends to capture or address ambiguities. Like say, the sentence would be, I have no love for cakes at all. Or and then the other sentence would be, I love eating cakes very much. That they would score as if they are very similar because it just checks the occurrence of the words and maybe similar meanings of the words. But now semantic similarity is able to get the context of sentences such that these nuances that would be present in longer lengths of texts are also captured. So we'll have a demo of semantic similarity also in a while, and we'll use Python for that. So those are the only two Python demos we'll do. And then the others will feature other tools as well. We have an interesting question, no, as a short break. So, ang data science ba is the nature of the work code writing or processing lang ng data? So, data analytics might just process the data, and depending on the tool, there might not be codes that you will write. And data analytics is a subfield of data science. But if we look at data science really and the scope of work and the task that it entails, there would really be, expect that there would be some code writing. Even if we use non-programming or non-coding tools, yeah, we can maybe do some data science work without the actual coding. Yeah, data science work can do away with you writing the code yourselves because the tools have already written code and implemented code for us, so that it's a matter of just pulling up these packages with codes that are written underneath and that underlie these packages. So we will end up not having to write code. So there are tools that will do that. So data science can have coding, cannot have coding, but the workflow is the same. You can achieve some components of the workflow with coding. You can achieve and finish some components of the workflow with or without coding. Sometimes even an entire workflow without coding it yourself because the tools have already coded it for us. So that's a long winding answer because I was thinking of the tools while I was considering the answers. No, so yeah, that's a good question. Valid. So those are NLP trends that we find now. Those are the state of the art, and we find many uses for them in daily life. We'll find many uses for them in our institutions, no? Like in government, there was a part my career and my life, where I worked and document and in document tuloy in government, and documents are so plenty, inter-office memos, this and this releases, this and this guidelines. NLP can do a lot with that, no? It can automatically categorize documents that are similar. It can categorize documents according to topics that are present in the document. So you don't have to do it manually. So imagine how NLP can enrich the record section of our government offices. So this is a challenge for our government officials that are in IT. Why don't you do NLP use cases and efficiently handle documents in the workplace? Not only for government, I guess that's true for all institutions. And then there was something that I was about to say, but so we'll end the NLP trends with this insight. No, the limits of my language means the limits of my world. So actually what I'm trying to say here is that language is limitless. It's verbal, it's non-verbal, it's interpersonal, it's intrapersonal. We even talk to ourselves, we even talk to our plants, and there's a lot that we can do. Social media discourse is a very rich source of corpora, and we can learn a lot of constructs that will enable businesses, enable our personal decisions in life, even when we do NLP projects using social media, curated texts and discourse, no? So that's NLP for us. So before we shift to the next subfield and look at the trends, we have I'm going to look at the next set of questions, because I'm more excited on the questions than on my the content that I'm sharing. I'm so excited to look at what you guys are thinking, what your questions are with data science. So there. So is it difficult ang code writing? Again, it's difficult. Difficulty is a construct that I feel is subjective and relative. Of course, there's this really parang sense of difficulty, no? Parang a specific measure na agreed upon level of difficulty. But nothing is really that difficult if you're passionate about it. Let me tell you a short anecdote, a short story. My son, he is my youngest son, he is deaf, and he has been profoundly deaf since birth, because when I was pregnant with him, short ano lang kwento, I had German measles. So I did not get the treatment for German measles kasi nga it might harm the baby inside. So when I had German measles, doon ko nalaman that I was pregnant, and so but we decided to continue, of course, and have him, and that's there's no question about that. And so he's studying now here in the US, and he is really so into IT, so into computers. And I feel that it's not a career for everybody. So if you just look at IT in itself, we might say that it's an agreed upon notion of IT in terms of difficulty is that it is a bit difficult. But because he likes it so much, he does not feel that it's so difficult. So I'm really just, I modesty aside, I'm just really proud of how he does well here in a field, and he's the only deaf student in his class, and he's earning good grades. So I've mentioned that to inspire our dear students and our budding data science professionals, no, to nothing is really so difficult if you're excited about it. So it can be, so the agreed upon notion, there's some difficulty. Why? Because it encompasses a lot of bodies of knowledge, and you need a lot of skills, but it's doable, and you may not feel the burden of it being difficult because you'll have one victory each time you learn a package, each time you execute a new model. So that's the difficulty question. All right, so I just want that our dear students in the audience today, a takeaway is for you to get motivated. If you don't get any technical inputs from this webinar, just get the motivation to explore these careers and prove that the Filipino talent is really global, is really competitive globally. Okay, so let's go to the next subfield. Oh, yes. Before we go to the next subfield, but continue putting in your questions. I'll answer them after the next subfield. But before that, we have here, what set of subjects or topics do we need to incorporate in our syllabi to at least introduce data science to info system students? Are there free online sources where we can search over the internet that you can recommend? I like this question a lot. Information system students, I feel so strongly about this. Info system students, this is your time to shine. You should be thriving in the age where data science is a sought after commodity. Why? Because at the core of information systems is what? Information, it's data, it's your turf, my dear ones, my dear students. So what topics do we need to incorporate to arm you, our dear info system students, so that you can pursue a career in data science? We have databases and the structure of data, where you learn data wrangling, where you learn metadata, where you learn joining tables. That's essential, no? And then you can also put in Python, even if you're not applying data science methods to Python, if you know how to program in Python, if Python is part of your curriculum, then the learning curve of learning Python for data science would not be so steep at all. And then, of course, we have as a core, we have our GE courses. You have your math, you have your algebra, we have our statistics, and these are the basics that can arm us for our data science careers. No? So, yeah, info system students, consider data science careers as an option. So, I really appreciate that. So now we go to the next subfield, which is computer vision. If in NLP, we teach the machine, we equip the machine to learn language, how we communicate, and give it corpus of communication artifacts. In computer vision, we teach the machine how to see objects, how to see segments of objects in an image. So computer vision, my dear colleagues, it focuses on image and video data rather than numeric or text data. As a downside, computer vision is computing resource extensive, no? So we have to have fattened resource if we're into computer vision research. Now, that's not a problem anymore because of the state of our machines now. So this is within the reach of individuals, of even small and medium scale enterprises. The goal of computer vision, the primary goal is understand the content of videos and still images. What is in this image? What would be in these frames of images in the video? It formulates useful information from them to solve an ever-widening array of problems. So that's the goal of computer vision. And we see computer vision everywhere in all aspects of life. In medicine, we have medical image processing that involves the speedy extraction of vital image data. Some would say, especially medical professionals, that diagnosis is a scary part to leave to the machine, to leave to just models. But the state of the art now are sophisticated enough to give some insights on diagnosis. So it will help proper diagnosis, but because of the context of this domain, because it's a life and death question, we still need the experts, no, for diagnosis. But medicine, bioinformatics, computational healthcare has improved strides, no? Then we also have autonomous vehicles. The first time I saw a driverless car, I was so scared. They have driverless cars already deployed here. It's a very active area of computer vision research because it detects like objects, so that to avoid a collision with objects, no? So these are computer vision solutions that are embedded. You recall the Internet of Intelligent Things, no? So ubiquitous computing and computer vision. Of course, there would be some ethical issues. I know most of you have read na this moral dilemma of these autonomous vehicles na given a choice of two objects and it will really need to select one, kung ano na lang babanggain niya, ano ang isa-save niya. That's the moral dilemma. But I'll not go into that philosophical debate. No? So next, computer vision and industrial use used for industries. Current uses include quality control, wherein computer vision systems inspect parts and finished products for defects. So it's in manufacturing pipelines. So we have this computer vision deployments for industries, for industrial uses. Then we also have smart agriculture. So kung ayaw nyo ng computational, you can put the word smart also. And we said, pero akin lang yung invento ha, I'm not satisfied with smart anymore. I would like it smarter. No? So instead of us calling smart agriculture, it can be smart agriculture 2.0 or smarter agriculture. So computer vision systems use optical sorting to remove unwanted materials from food products. That's one use case. Also, computer vision also is used in species classification, like our durian breed classification can also be done using computer vision. Leaf disease detection, we can also do that using leaf detection, and many more, a lot more that you can do. So one computer vision use case we have already seen. A classic was that of the handwritten digits. So it's also used in, that's the term na hinanap ko, yung digital forensics, no? Also in authorship, no? So sa museum curators, when they have this artifact and want to validate na totoo ba na handwriting ito ni such and such renowned person who already passed away. So computer vision also is used in the arts and humanities. No? So those are computer vision use cases. Now I'll open one Q&A again. Put in more. Okay, so we have one. Makakahabol pa po kaya kami if you choose to change our career to data science analytics, if you're already, say, in our late 30s or early 40s? Yes, I can confidently say yes, because I was in my early career, after I graduated sa pamantasan, I was a programmer and a software engineer. And then, so I've been that for, say, a good, maybe almost a little below 10 years. And then after that, I felt na I wanted to teach. So I joined the academy. And then, so I love teaching so much. Ang problem with us doing so well in the academe is that we get to be assigned admin positions, which in the first place, we did not sign up for. So kaya nga tayo umalis sa industry and join the academe because we wanted to teach, and then we have to give service and help our institutions. Syempre naman, no, because there's academes just do not, there has to be some policies in place, some curriculum review, some designing. So we get to help out in those roles such that limited na ang engagement natin with students. So I was in the academe doing work, doing mentoring students, teaching, doing some admin work, doing some MIS stuff for a little over 10 years also. And then, so I did my PhD, and then I felt na I was not able to concentrate much. Hindi ako nakapag-aral. Hindi ko naaral ang mga gusto kong aralin because I was so busy with work. I was doing my graduate studies, and I was serving the institution for some academic admin post. Then I was doing some teaching. So feeling ko, I learned just the bare minimum to finish, to acquire my degree. And so I promised myself I would do data science work. So gladly I was given the chance, and now I'm doing what I dream of doing. So even as data science can be qualified as one of the not so easy fields, I was excited to learn it. I was excited to apply myself. And so that opened a new career for me. And you are in your early 40s. I have just approached my 50s. So yeah, makakahabol. That's they do not even like for industries. I know that we need to in the interim lang naman ako nandito and living this dream. We don't know what the future will hold, but industries outside our beloved country, they will not even like consider the age. It's really just the skill. So it's a sought after commodity regardless of the age. Then we also do our country, make our country proud, because then they discover our talent, our passion, no? And then they see na truly Filipinos do well and they excel at what they do. They're passionate. So it's a feather in our cap when we also explore outside the horizons that we are in. Kung saan tayo nilagay, let's do our best. Okay, so that's computer vision for us as a trend. And so I will end computer vision naman with this nugget. Your vision becomes clear when you look inside your heart. So if you look inside your heart, nandun ang iyong vision board. More than just this vision board that we create outside in our whiteboards, no, in our journals, put your vision in your heart. It will become more clear to see when it's inside your heart. Who looks outside dreams? Who looks inside awakens? So it's something that human vision can do and computer vision cannot. Okay, so a little pause for impact. Sure. Okay, so that's the end of the trend. We will now go to our last slide deck, but this is now on getting our hands dirty. And this is the most exciting part. If only I can find my slide deck. No, I'm just kidding. I have a bit of an organized folder for this webinar. I'm just a little slow there. So this would be, I did not share my screen. Let me close you. And then PowerPoint slide deck 4. Share my screen again. Kaya yan, sir. I have a sentiment in the Q&A. Age range does not matter. Passion does. No programming skills, okay lang yan. It's really very easy. It will be. Just learn it a day at a time. But mind you, until now, I cannot like even do a task without Googling. So Google is our best friend. We're not expected to memorize everything. Just know the workflow, just know your motivations, the questions that you want to ask, and then Google is there to help you every day at every task. Okay. Yes, we have YouTube and Google. YouTube's our best friend. Only if I can find my share screen button there. It's not, I don't want to share just the PowerPoint. I'll share the desktop because we'll be shifting through, changing to a lot of screens in this part. Okay. We are almost done. This is the 4th slide deck, but this is a rather long slide deck, but it's the most exciting part, so brace yourselves. We will now look at data science use cases and look at the tools that we have for data science. So I have shared my screen, and it's data science use cases in industries module 4. I hope that's what you're seeing. But before the use cases, here are the tools. So I would like to introduce you to RapidMiner. It's proprietary, but if you're in the academe, you can use it for free. There's also like, there's also an edition that you can use without paying anything. So let me play just a message in the Q&A if you can, if the audio isn't that clear. Wait, I will unshare. I will like exit. Oh, I will exit the, because if I click my link, it will open. I want it to open in Google Chrome. So this is the RapidMiner page. They have a RapidMiner Academy, which you can view. There's also a lot of RapidMiner videos online and resources. And what's good with RapidMiner is that even for those who are using Python, even for you, dear students, no, you're not allowed to use RapidMiner for your projects, right? But you can get workflows that will help you design your own projects, because RapidMiner has existing workflows, like how to approach a classification problem, no? And it has the steps that you can copy. So that's a hack that I want to teach. But I'm playing this video just so you could see the interface, and this would be one of the tools where you won't need to use to do any coding. Kaso lang, when you look at data science jobs in LinkedIn or some other portals, they do not really look for RapidMiner expertise. But if you're already in a company, feel free to introduce RapidMiner or use it on your own. No? So let's do this. I hope.
As you undertake data prep, modeling, validation, and operationalization of your analytics processes. Next to the default views, you can find the option to start RapidMiner on Turbo Prep and RapidMiner.
Are you able to hear the audio? I open the chat. Okay, thank you. Thank you very much for that feedback. Let's do this again.
Hello and welcome to this Getting Started with RapidMiner tutorial. In this tutorial, we take a quick look at our user interface. We'll talk about the operators, the repository, the process panel, the views, and the global search. We'll see the functionality of ports, parameters, and of course, we'll have a quick look at where to find help. But first, let's start with the different views. Once we open RapidMiner Studio, we end up in the design view. Next to it, there's the results view. Both views can be described as work areas, which are equipped and optimized to carry out specific tasks as you undertake data prep, modeling, validation, and operationalization of your analytics processes. Next to the default views, you can find the option to start RapidMiner Auto Turbo Prep and RapidMiner Auto Model. Both are great to accelerate everything you want to do when building real data science solutions, no matter if you're just starting or if you're already an experienced data scientist. In the center of the design view, you can see the important process panel, which is used to design any process, for example, data loading, outlier detection, or forecasting. Processes are comprised of a set of connected operators, which can be understood as the building blocks. By default, the operators panel is open and placed in the bottom left. You can see the different areas in the operators panel called data access, blending, cleansing, modeling, and so on. Each of them has a rich set of operators. To get started with a very simple process, we need to place an operator into the process panel. To do that, let's extend one of our operator folders, in our case, data access. Now we can select the retrieve operator and drag and drop into the process panel. In case you don't know in which folder to find the operator you want or which operator to use, you can just type the name in the search field. We select our retrieve operator by clicking to apply further settings. You can see that the parameters panel on the top right has changed, and we can now use the folder icon to select the file which we want to load. We will select the Titanic dataset, which is preloaded in RapidMiner Studio. In order to run our very simple process, we only need to connect the ports, indicated here by a small half circle with the word out, to our results port on the right. For a list of all the port abbreviations, we recommend you visit docs.rapidminer.com, where you'll find them in the Getting Started glossary under ports. Now back to our simple process. When we select the Run button, RapidMiner executes the process and automatically displays the results view. Here, our dataset is displayed by default as a table. As you can see, we have 1,309 examples and 12 regular attributes. Attributes is in RapidMiner the general term for a column. Examples refers to the rows of our table. There are also further options displayed to analyze our data set quickly, such as statistics, where you can, for example, see the number of missing values, or visualizations or annotations. But we will come back to those in a later tutorial. So let's go back to our design view and talk briefly about adjusting the layout of our views. If we want to resize the area of a panel, such as the process panel, we can do that by clicking and dragging the boundaries between panels. In case we want to relocate a panel, we can do that by simply grabbing the panel tab and drag and drop it into a different location. You'll see a shadow appearing, which indicates where our panel will be placed once we release it. If you see a blue arrow on the tab, this indicates that the panel will be popped out and will be available as a free-floating window. In case you accidentally closed one of your panels, you can bring it back by opening the View menu, Show Panel, and then we select the panel which you closed. Finally, you only need to reposition it to the location where you want to use it. If you want to return it to the default view, you can simply select Restore Default View from the View menu. In the top left of our default design view, we find the repository panel, through which you can access data and your RapidMiner processes. Have a look around to see the different features available. We recommend as a practice that wherever you start a new project, that you create a new repository with 2 subfolders, one called Data and one called Processes. This way you can keep those important elements separate in your latest repository. To create a new repository, click on the drop-down menu and select the entry Create Repository. You can create your folders in the same manner. If you want to find a certain process that you stored in a folder or a repository, you can use the global search. As you can guess from the name global search, and as you can see from the drop-down here, it does allow you to search for other things as well. I'll just type data as an example, and you can see that besides all the processes with the term data, also downloadable extensions, operators for drag and drop, and even actions are made available. In the lower right of the default view, you can see the Help panel. Each operator has its own help section, and often you can find tutorial processes in that section to help you better understand each operator. For example, if you want to look at the tutorial process for our operator retrieve, You just need to select the operator and then select the link in the help panel. If we click the link, the tutorial process will open, and we can test the tutorial process by selecting the Run option. As before, the loaded table will be displayed in the results view. Let's now return to our design view. This concludes our brief introduction to the user interface of.
Right, so that's the user interface of RapidMiner, but I want to show another video from RapidMiner again. I know I was just supposed to show you that tool because I want to highlight this feature of RapidMiner, and I've been using this feature a couple of times, and it's the auto model feature. In data science, let me backtrack a bit. In data science, the choice of machine learning methods and algorithms that you will use will be, syempre, first, primarily dictated by the goal, the task at hand, the goal of the organization or the institution. But technically, if we detach from that, from the domain purpose, the choice of algorithm is dictated by the data. Is your data numeric? Is your data categorical? Is your data, what are the ranges of your data? Are your data normally distributed? Or is this binomial? No? Is there a linear relation? Do you hypothesize a linear relationship in the data? So again, let me stress that the choice of algorithm and approach is dictated by the characteristics of your data set. And so RapidMiner has an auto model feature. All you need to do is put in the data set. It will infer, it will like suggest and create a workflow considering your data set. You'll be surprised at what it can suggest you will do and use given your own data set. So you can explore that on your own. RapidMiner is easy to download. You just need to register. Of course. But it's easy. I have used it like a couple of times when I need something very fast or just to verify something that I've created from scratch in Python or in R. Then RapidMiner is a tool that we need. So we don't want to click you. So this is our last RapidMiner clip. It's just a clip. It's not a full-blown tutorial. And this is a public domain, so we don't have proprietary or copyright issues with using this clip on a public space. So
Both of the
I'll shut up.
Typing is a challenge for beginners and advanced users alike. Finding a first set of good models quickly is what advanced users want to do, and getting to a suitable model which fits your task is often the problem for beginners. Both of these challenges can be solved with the auto model feature so that the beginner can create a model with confidence, and for the advanced user, it saves a lot of time getting started. So let's see how it works. The first step is to select some data. You can either choose some data you have in your repository, which is your local archive, or you can import it from a file or database. We will, for most of this demo, use one of the samples which gets shipped with RapidMiner Studio. A good choice is the Titanic dataset, which has 1,300 examples and 12 columns of different data types, with a good mix of numeric and polynomial attributes. Now for the data set, as you can guess from the name, we have a collection of the known information about the passengers which embarked on the famous maiden voyage of the RMS Titanic from England to New York. The example set contains, besides personal data like age, gender, and number of family members on board, also information about the class in which they traveled, ticket price, or where they boarded the ship. Now, of course, with this data, the most interesting challenge is to try and model the potential survival of each passenger, and therefore the task at hand is a classification problem. Our label or target variable is obviously the attribute named survived. In this next step, we're asked to identify which value of the label is for us the important one. In our case, we have only 2 classes and we're interested in yes. You can also rename the classes or reduce the number of values by mapping several classes to the same value. Now, this next page is particularly interesting and important. Every attribute of our example set is shown here with a tick box, a traffic light, and a quality chart. The status colors mean the following. Red should most likely be excluded from the model creation process. Orange, make sure to double check if you really want to select this attribute as input. Green, this seems to be an important input for model generation. Selecting the right inputs for modeling is important to make sure you include every relevant aspect, but it's also important to exclude unimportant features, which only increase the runtime, so make sure to review this carefully. Here on the right, we have our information panel, which will help to understand the quality chart better. The quality chart gives you an indication on correlation between an attribute and the label, the ID-ness, the stability, and the fraction of missing values in a column. As mentioned here, in general, you should prefer columns with low values for missing, stability, and ID-ness. A lot of missing entries will not help to find patterns for explanation, so that's a no-brainer. Now you can see why cabin is flagged to be excluded as clutter. Stability is high if the values in an attribute showing little to no variation. Again, not helpful for pattern identification in that case. ID-ness tells you how much a column is like a unique identifier, which means each value appears only once in an attribute, and therefore, again, is not useful in finding patterns. A random ID like the ticket number or something as specific as the name of a passenger clearly is of that type. Lifeboat is flagged orange, which tells us that this is something where RapidMiner is unclear if it's a good idea to select this attribute. Missing is high because most people didn't make it to 1, and therefore these values are missing. At the same time, the correlation between this attribute and the target, which we want to predict, is very high, so we might have a great proxy here. Our challenge is to predict if someone is going to survive, assuming the incident has not happened yet, but the information on lifeboats is a result of the disaster. So due to the causality of the correlation, we have to exclude the attribute. Now on this page, we get a pre-selected subset of suitable models with respect to our task and to the size of our example set. For some of them, regularization or optimization is very useful to get a better performance, so we can choose to include this automatically here. If you're concerned about the runtime, you can decide to untick it, but it will be best to leave it on. Besides creating the models and some helpful analytics on each, we'll also create a general correlation matrix and an overview on the importance of the columns. You can turn this off here in case you're not interested in that, but we won't, so we can show you what it looks like. All right, now let's hit the run button. This will take a bit of time because we're calculating all the models, including validation and optimization. By selecting the overview, we can, however, look at what has happened so far already now. Okay, the last entry here is empty, so it is the gradient boosted tree, which is taking some more time. That's not surprising because it is an ensemble model and therefore is calculating many different trees. In the table below the graphs, we get the runtime of each model and a selection of performance matrices. If you're not sure which one to look at, then we recommend considering accuracy, but also the robust AUC, which stands for area under the curve. As I click on the rock comparison, you can nicely see the curves from which the AUC is calculated. To understand more about the rock curves and the different quality measures, please refer to the tutorials on validation and model identification, respectively. Now, as we switch back to the overview, we see that so far, random forest is the model with the highest AUC, but also required a multiple of the other models' runtime. For the gain of only about 0.5% higher AUC, we had to pay a high price with the amount of runtime. The same applies to our gradient boosted tree, which has just been completed. So the auto model feature provides a great help here for you to find the most economic approach between calculation time and performance. Before we look into the details which are provided with each model, let's first look into the general section up here. The data section is obvious, so I'll move on directly to weights. This section helps you to quickly see which of the attributes were actually the most relevant for the model's predictions. In the case of our Titanic example, clearly the gender is the most dominant one, but it is immediately followed by monetary attributes. You can see something similar in the correlations, namely that gender and survival are comparably higher correlated, as well as passenger class and fare with each other and with survival. Okay, now here at the bottom, we can see some further helpful details about each of the models that have been chosen. For the decision tree, you get a nice chart and the full confusion matrix with all performance details. In the optimal parameters, you can see which parameters, if any, have been optimized and what the best values are. The last two entries shown here are lift chart and simulator. The simulator is very helpful to run through some what-if scenarios, and it includes the option to ask RapidMiner to perform optimization. For example, you can ask for the following optimization. How can I maximize my chance to survive given that I'm a 40-year-old man who embarks on the voyage in Cherbourg? Now you can see that even with optimized conditions, the chance for survival in this case can only be increased to slightly above random chance. And since age and gender were predetermined, you'd better make sure to travel in first class as the biggest supporter of a positive survival outcome. The lift chart is often used, for example, during marketing campaigns and helps to assess the impact of using a model to identify campaign targets as compared to just sending out messages randomly. Last thing to demonstrate here is what happens if you have some examples in your data set that you want to predict. For that, we'll select the customer data, which we've been using also in the other tutorials. Check out the video on data loading to find out how it's imported. As you can see, the churn label contains some missing values. We will go through the next steps here rapidly since we've just explained them, and to speed things up even more, we'll avoid the calculation-intensive gradient boosted tree model. While the remaining models are calculated, we can already see the predictions for our unlabeled data as made by the naive Bayes model. The green and red colors are helping you to understand why an example was classified positive or negative. So this example here was classified as loyal despite the fact that the customer is female, which otherwise would have been more an argument for churn. But if you look at the confidence, then this is not a very strong case. This example here in contrast was classified as churn with all values across the 4 attributes supporting this decision with a very high confidence. If you're an experienced user, then one thing you may have been asking yourself during this demo more than once is the question, what if I want to do something different than the options provided? For example, what if I want to optimize other parameters? In that case, you can simply click down here on Open Process, and you're free to change or add anything you like, with the big advantage that you won't need to start from scratch. So Auto Model is not a black box which you can't control, but rather a customizable and transparent feature to support your productivity. With this, we want to end this tutorial, and we thank you very much for watching.
So that is why I like RapidMiner so much, but unfortunately though I use it like maybe 10% or lower of the time that I do machine learning work, because I use Python and R because I want more flexibility, but RapidMiner is able to, forgot to turn on my screen, sorry, is able to like, it's a hack. It will give me it will validate what I have initially in mind on how to implement my models, no? On one way of implementing my models. Again, as with life, there's more than one way to skin a cat, meaning there are many solutions. Yeah, it's really amazing. It's beautiful. I agree with that feedback. Okay, so our next tool is also not requiring coding. It's also not like RapidMiner. RapidMiner is drag and drop. Here, it's a more crude interface, but it gets some of the basic data science jobs done. And that's what is important. This intro talks about the tool, but it does not show the interface. But don't worry, I will work on the Titanic dataset later using this tool. So I'll do the demo myself. Okay, so here's the next tool. I'll copy the link first. this is the most lightweight tool. So it's easy to download, it's easy to install, it's easy to run. It won't take a whole lot to execute it, a lot of memory of computing resource to execute it. This is the developer who created and made available this tool. At itago natin siya sa pangalang Weka. So here, again, this is public domain. We don't have copyright issues. I mean, this is available. I don't want to open it in YouTube because you'd see my recommendation videos. You'd see what I watch. So let's just watch it here.
Hello, my name is Ian Witten and I'm from the University of Waikato here.
Hi. My internet's acting up. Well, anyway, he's talking about Weka and
Here in New Zealand, and I want to tell you about our new free
Okay, so I'll be telling you about it. And
online.
there, that's Professor Ian Witten, and they developed Weka. Let me I'll not do a demo first, but let me show you how it looks like. When we share our screen, and then, so we reveal our lives to the world, no? That's why it's so scary to have your screen shared. What am I looking for again? Weka. So this is how it looks like. I'm running it in a Mac. So when you run it the first time, it will not allow you to run it. Just run it again the second time. It opened because I opened it a while ago. So just for those using a Mac, you just right click and then click the open anyway. So it's University of Waikato. This is a fairly old version, a release maybe, because I've downloaded it like many years ago, but it still serves the purpose. Although I don't use this for work because I use Python but I like do this when I need to demo for some audience. So this is just the cute little interface of Weka. Well, when you click on Explorer, you'd see data science tasks in the tabs. You see here, you have pre-process, classification, which will also have regression functions. You have clustering, association rule mining. You have some tasks where you'd like to do feature selection or select attributes. There's some visualization, not as maybe mine's an old version, but I like Python's visualization better, the Seaborn package. And then this is a package that you won't have for the default installation because I did some semi-supervised learning, which we did not really do today. So you can add on extensions to the vanilla Weka release, no? So we'll work with this in a while. So this is a second non-coding tool, and yeah, it serves the purpose. You'll appreciate this also. So our next tool is this is when you have this in your CVs, you would, I mean, companies would seek you, would run after you. no? It has a really sophisticated visualization. Well, yeah. So this is a video that they make available for the public. It's in their website. Just an introduction to what Tableau is.
Tableau empowers everyone to see and understand their data. It's business intelligence for your entire organization. Explore and analyze data in seconds. Just drag and drop to discover trends and outliers. Or use natural language to go from question to answer in an instant. Connect to the data you care about, whether it's a spreadsheet, database, or big data. Access data warehouses or cloud data. Tableau Prep helps you quickly and confidently transform and shape your data for analysis. Easily combine data from multiple sources. See all your data at a glance with Prep Builder's visual and direct interface. Smart grouping algorithms make it easy to reorganize your data. Then publish and schedule your flows with Prep Conductor. Or open the output directly in Tableau Desktop for analysis, where you can ask questions, change your perspective, and reveal deeper meaning. Transform your data into powerful interactive dashboards. Securely share your data and dashboards with Tableau Online or Tableau Server, so everyone in your organization can ask and answer their own questions right from a browser, tablet, or phone. Whether you want a fully hosted solution like Tableau Online, or to manage your own Tableau server on premises or in the cloud, the choice is yours. Everyone in your organization can access data and dashboards to explore and find their own insights in a trusted and secure environment. Tableau's management tools give you control over everything, from user permissions to data source connectivity, and the visibility you need to support your deployment. Tableau naturally fits within the fabric of your business, so you can easily scale from small teams to full organizations with thousands of users. Tableau, see and understand your data.
Right, so that's Tableau for us. Although I want to qualify that Tableau is more of a data analytics tool. All right, and then we also have Power BI. So this is their demo video.
Nancy is a marketing manager and key decision maker. She's been informed that her team's revenue was lower than anticipated this quarter.
If I do, sorry.
Nancy needs a tool that will allow her to delve deep into last quarter's numbers to come up with a plan of action for how they can increase revenue next quarter. Nancy relies on the ability to collaborate quickly within her organization, whether she's on the go or in the office. Microsoft Power BI is the tool that delivers the data she needs, wherever she is, and it's simpler and faster than ever before. Microsoft Power BI gives Nancy the ability to collaborate quickly within her organization. Apps like Salesforce, Dynamics, Adobe, and Google Analytics can be directly embedded, reducing workflow redundancies and creating a one-stop shop for her data needs. Microsoft Power BI gives her the ability to visualize data in an interactive, intuitive way, so she can consume quickly and delve deeper into the data with a targeted approach. Any Microsoft Power BI report seamlessly integrates across Microsoft applications, such as Teams and SharePoint Online. This gives Nancy the ability to consume and share information across the organization in just a few clicks. Along with familiar tools like Excel, Power BI gives Nancy the toolkit she needs to read data, create insights, forecast, and implement a plan of action on a wide range of business priorities. Thanks to Microsoft Power BI, Nancy has the insights she needs to make informed decisions. Go from data to insights in minutes. Any data, any way, anywhere.
Right, so that's Power BI. Again, like Tableau, it's more a data analytics tool than data science tool. And then lastly, I mean, these are not the only tools we have. This one now involves, so the tools that I've showcased are those that I've used that do not require coding, but I'm heavily reliant on coding. And so I use Python and R. And this last one is just a resource that I like to give technical audience and students in the computer studies field. This is a resource. You can't do away with data science without scikit-learn. So scikit-learn has made sample notebooks, sample implementations across many domains. So for classification algorithms, it has notebooks for each of this. So just visit the scikit-learn documentation if you're not still using it, but I bet that most of you, those in the audience that are doing technical work. So this is clustering in different fields, samples. This would be covariance estimation, cross decomposition, decision trees. We'll do a demo for decision tree in a while, but I'll use Weka for that. Etc. etc. Ensemble methods, just a quick word before we go into our afternoon break. Ensemble method, or the ensemble machine learning, dear colleagues, is an approach where you create many base classifiers. You create many models, and then you will either aggregate the predictions of these models or use the outputs of these models and create a second model that use the outputs as features. That's called meta learning and ensemble machine learning. So ensemble would involve implementing many models and then getting the best model or the best result, right? So to be simplistic about it, but there can be more complex descriptions. So this would be a good resource. So we will now look at use cases, but we will not just be discussing them, but instead we'll implement them using the different tools. So we'd appreciate them at a deeper level. But before we do that, I just like to answer some questions or insights that our colleagues have posted in the Q&A facility. So first we have how to start to become a web developer. I'm a newbie, so any suggestion po? So if you want to do that, if you want to be a web developer, you can create, even if you don't have specific clients yet, you can create common use cases, no? Like create web apps that are needed by institutions. So say something for appointment setting so that you have it in your portfolio and then you can reuse it. You can do freelance at first. So granting that you also already studied and acquire the technical skills. So it would require a lot of practice and reading and executing your code. Then coming up with a full portfolio, then you can have a full launch of career, all right? And then as an IT major in development fresh grad, can I apply in a data science field for my first job? Yes, you may do that because there are some industries that are fairly open, not really. It's a bit difficult to find those, but you might be able to find opportunities that allow maybe for internships at first, and then if you perform well, if they see that you are self-propelling, you can self-learn, then you might be given a chance, no, for a full proper tenured post in the industry. So start learning on your own kahit na hindi full-blown courses. Put it in your CV. Look at, for everybody who's interested in pursuing a data science career, put data science or data learning in your job search alerts in LinkedIn, and then you'll find the skills that they need, the platforms that they want you to be familiar with, and then start learning this platform so that you can add one skill at a time, one platform at a time. So that's one technique that you can do. For me, so a question also asked if what's better, to use the tools to manage your data or create your own and managing the data. Because I use Python already in most of the machine learning work, so I create my own tools. So I rarely write from scratch anymore because I've been at it for some time already. So if I say I need like data aggregation or transforming data sets from long format to short format, or say I'd like to clean Twitter data, tweets that I have scraped, or news articles that I have scraped over the web and need to do some pre-processing, I have already written my code for that. So I have my own library. So yes, I prefer to write my own, mainly because baka may pagka-OC ako. I want to see what's happening under the hood. But the tools, they're reliable. You can use them. So next, if we use the link or the sample platform, it means less coding na po ba? Bali mag-set or select lang tayo, depende sa... Yes. So if we use like RapidMiner, if you use Weka for your data science work, if you use Tableau and Power BI for your data analytics and data viz work, there would be less coding. Sometimes, for some projects, no coding at all. So what would be a good work experience when getting into data science, data analytics? It would be good to have some experience on data pre-processing, data collection of data that's available on the web, cleaning that data, and doing data analytics, which will be featured in tomorrow's webinar. So if you have some time, to all participants, you're also invited to register. I don't know if registration is still open. We can verify with our very able DICT officials. So that's a good work experience to have when getting into data science. So also doing like preliminary work that resembles actual data science, that's also a good experience to put on your CVs, to fatten your CVs, no? The artifact of your qualifications. So a fresh graduate of computer science can take data science as his or her first job, even without enough knowledge in programming languages, especially in Python. And of course, just only know the basics of Excel. Yeah, actually, we have a success story. I do know data science, full-blown data science professionals now who found themselves in the field unknowingly, and they have been doing Excel at the onset. And then, is our programming used in data science depending on industries? So if you're interested to work with, say, Google, or if you're interested to work with IBM, look at what they are using, the platform they are using. If you're interested to work in academic institutions, like where I'm working with here, yes, our programming or scripting is widely used. So keep those questions and insights coming. We will get to them. We'll answer them as we go through the webinar. So I don't want to delay and have the demos any longer. So here you go. Our first workshop for this webinar is association rule mining. Let's create a customer movie preferences. So for the rest of the demos, I already have ready data sets, but for this one, I just wanted to show this part, no, where we create data sets. So that's why I have my Excel open. Oops. So we'll do association rule mining. And the task is, I want to know customer movie preferences, no? So I'll explain its relevance to a specific institution later on. So say I have like client ID here. We will end up taking this out anyway. So say I have like this client, and I'd like to know the preferences of people in terms of the movies that they watch. Movies na gagastusan talaga nila to go to a theater. Ano yung worth na gastusan nila? So, categories of movies, say rom-com, say sci-fi, say action, or pure comedy, documentary, and horror, or say ang uso ngayon, which bandwagon, Korean something, or Asian, or international genre. How do you even call that? I'm not a humanities practitioner. So say si client ID 1, mahilig siya sa rom-com and sa sci-fi and sa action, but not really a fan of comedy, documentary, horror, or Korean. So these are the values that we have. So say for example, well, how many do we have here? I have like a couple of clients. So it's not really as big as the data, but let's just create one screen full and then have random values here. Pero you know already what they stand for. Just to have an efficient use of our time. So say we have interviewed these people and this is the data that we have gathered, no? Because sometimes, I mean, most of the time, data science would also be involved, or data analytics would also involve gathering the data. So let's save our file as a CSV file. Let's put it in the data sets, which we will call movie2, comma separated file. So we have that. Let's close it. And then for this demo, for this specific use case, let's do Weka just to demo and appreciate how what Weka offers. So our files are in Weka's default file formats are ARFF, but it can also read a lot, no? So a lot of formats. So you have your JSON files, then we would like to access CSV files inside the datasets folder, specifically the one that we just created now, which is movie2.csv. There. So Weka will give us already univariate statistics. And if we go into the technical details of data science, which is not the purpose of our webinar today, you must need to do univariate statistics first. You must need to understand individual variables first before you even look at your data set using a multivariate lens. You need to understand each variable individually. So we'd like to look at the associations between the preferences of our customers in terms of a movie genre. So we're not really interested in looking at the client ID. So let's just remove that. So I clicked on it and now I'm clicking on remove. Now I only have rom-com. The thing is, if you look at this pane, it treated our variables as numeric, which they are not because they're actually nominal, meaning 0 stands for a no and 1 stands for yes, they prefer this genre. So we must tell Weka that they should not be treated as numeric. So we can choose one of Weka's many filters. We will use an unsupervised filter because it will just do it for us automatically over attributes. Yeah, attributes. And then we'll find numeric to nominal. So let's look for that. Numeric to nominal. When you click on this area, you can set or change the default settings. So let me just click here, but I'm not changing the default settings because I want all attributes from first to last to be changed from numeric into nominal. So I'll just either click cancel or okay. That would be fine. And then you see this apply button. I will click on apply and voila. You can see from the visualization and the descriptive statistics here that instead of reporting statistics that would reflect the attribute being numeric, kasi kanina nakita nyo, di ba? Mean, standard deviation. Now it does not do that. It actually is now treating the variables as nominal, and the appropriate descriptive statistics for nominal variables would be, of course, count per category. So this would mean that for this variable, we have 13 who answered no and 16 who answered 1 for rom-com. Then we have that for sci-fi, for action, comedy, documentary, horror, Korean. We have all those. So now we are ready to extract association rules from our data set. So we will click on the Associate tab, and you can select the algorithms you want. You can use filtered associator, you can use FP growth. We did not dive into the differences of these algorithms because we'll save that for your technical. You can save that for technical dive into data science and machine learning. So we'll just use a priori. So whatever you highlight, that's what will be used. Will be. So let's close that because I don't want to use FP growth. I want a priori. Just use default settings. The metrics here, as I've mentioned this morning, would be confidence of the rule. So how many occurred? You have 9, you can derive like 10 or 100 rules, no? So I'll talk about that in a while. Let's see if with a confidence setting of 0.9, we are able to derive rules. Meron pang other measures, the lift, no? Well, that's also another measure, but let's use confidence for now and see if it is able to derive rules. Oh yes, they are able. There are rules that do exist and are derived. So here is how we interpret our rules. From the data set we have, people who like rom-com and do not like sci-fi do not also like action. Second rule, so there are 10 of this, and all 10 do not like action. We also have people who like rom-com and documentary. There are 9 of them from our data set, and they don't like action. So that's how we'll interpret this Weka result. Now, if we apply this to our institutions, say ako yung may negosyo and ako yung manager ng theaters, no? And this will aid me in my decision on what types of movies I will air on specific screening dates. So if I want people to visit me, I will visit the theaters on specific screening dates. I will make sure na I will have rom-com, something of a rom-com kung may kasabay ako na sci-fi. So depende sa goal ko, but this will something that I would definitely use. Example, kung gusto ko na people who are already there would jump to another theater. Ay, ganahan, I like rom-com and I like comedy, so I will together. So I will put rom-com and comedy and the same screening dates, no? So if I see them occurring together, documentary and Korean being a yes and sci-fi being a no, so I will not put sci-fi when I have documentary and Korean because they won't really watch sci-fi anyway. So you can look at these combinations of rules and aid your decisions, no? Logistics. Now, for our IT students or IT professionals in the audience, how do you create or enrich your, say, your thesis or your project with machine learning? If you see, these rules are just if-then sets. So if you are able to extract if-then rules, you will be able to code, to include this in your code. And now your app, your web app, your thesis already is implementing association rule mining. So your thesis, which is a recommender system, underneath that, it's machine learning powered. It has association rule mining. In fact, it has a priori association rule mining. So that's how easy it is to elevate information systems in organizations. You can embed machine learning in your organizations, in your information systems. So people in MIS units, let's enable our IS deployments with machine learning wisdom and insights. No, you have the data after all. It's so easy. No, so that's I hope that insight excites everybody and would like to dive into this immediately. So that's our first demo. Customer preferences and association rule mining, brought to you by WECA. Our next use case is also in, we'll use WECA. This time, it's an example of regression. If you recall our discussion in the morning. So, let us go to WECA once again. The goal is to predict. I'll tell you something when I've uploaded the data. So let's open our data set, which is the breast cancer data set. This is a publicly available data set also for those learning. Breast cancer data set. There you go. And what you're trying to predict here would be, so you have these specific attributes for instances, no, of people with some growth on the breast, no, and we would like to detect if by looking at the characteristics or attributes of this growth, if it's the propensity of people for having breast cancer. So our attributes are the radius, the mean radius of that growth, the texture, perimeter, area, smoothness, so on and so forth. And our target variable is did that person have breast cancer or not? So it's a 0 and 1. Pero if you see, it's still the target variable was also treated as numeric. We have numeric candidate predictors, but supposedly the target variable is nominal. So it's categorical. So it's actually, even if we're using regression, we're doing a classification task. Hence, there's a specific regression algorithm or approach or tool for this. When you have continuous or numeric candidate predictors, and yet what the variable that you're trying to predict, your dependent variable, is nominal, you can use logistic regression. Let us first convert target to nominal. So again, How did we do that earlier? Let's go to unsupervised. Let's go to attribute. And what we want to do is numeric to nominal, but we don't want to convert everything, just the last one. So it's not first to last, but just the last attribute. So I'll set that to OK and click apply, and there you see it. Target is now nominal. It now has counts. Apparently, our data set has 0 instances na yung growth is not breast cancer, and 357, did I say 0 instances? Let me repeat that. We have 212 instances na 0, meaning yung growth is not breast cancer, and we have 357 instances in our data set na 1, which implies that the growth is, that observation is an instance of breast cancer. So now what we're trying to do is come up with our predictive model. So we'll click the classify tab and look for logistic regression, which is under here sa functions, and then say select any. So if you find in WECA, dear colleagues, what is like disabled, sorry, again, I don't want to use the word like unnecessarily. It's a bad habit that I acquired, talking to people, always using the word like. So what you see disabled are methods that are not appropriate given your data set. So there's that level of intelligence or detection that WECA does, no, given your data set. So it sees that given our data set, we can use logistic regression models and some other variations. So now we'll select simple logistic. These are options for testing. You can go on ahead and read more about coming up with models that are statistically correct, but we'll not go into that today because we'll just have high-level appreciation. So we'll now start our modeling. And so let's wait a while. This is our model performance. We have here correct classifications are 97%. Good. We have incorrect classifications, just a mere 2.81%. That's acceptable. A kappa score penalizes incorrect classifications, but the higher it is to 1, meaning the better, no, our performance, our model's performance is good. So we also have detailed accuracy by class here. We can read about other measures of performance. Almost always, accuracy or correct classification would not be enough. That's why we would look at some other measures of performance, because incorrect classifications might be costly, most especially in healthcare. No, you can like, ayan na naman, I'm sorry. It's so costly to predict somebody has COVID when actually he does not have COVID. So we penalize. We should not only focus on correct classifications, but we look at these other measures. And the formula for these other measures are based on the confusion matrix. The confusion matrix tells us that we predicted A when it's actually A. We predicted B when it's actually B. When we say A is the absence of cancer, so when it's not cancer, 201 of it not being cancer, we predicted that correctly. But 11 na hindi pala cancer, we said that it's cancerous. Dito naman, we predicted that it's cancerous and it's actually cancerous. 5, we said na it's not cancerous, but it's actually cancerous. So that's the danger, no? Imagine telling just 5 people na you have cancer when you don't, or the other way around. Telling you have cancer, you don't have cancer when you don't. So that's very critical in healthcare. That's why we don't just focus on correct classifications, but we penalize incorrect classifications as well. So that is classification, that's prediction, classification and prediction brought to you by WECA. So, and that's for healthcare. I just need to plug my machine. So, change venue na naman tayo. Really quick. While I'm setting up, we have some questions. Easiest way to show or prove data in our thesis. Sorry, I might have checked that question too long. I cannot recall it anymore, but maybe you can give me some more context on the question, no? I cannot follow the trail of thought anymore. What this is. This is the same thing Google Form is doing, since we can also access stat analysis using data from respondents. Yes, that's very accurate. That's what Google Forms and Google Analytics is also able to do. Yeah. So now we go to the next demo. We have a classification. This time, I'll introduce you to R. Let me open R. So this is the icon for R, and R Studio is like a higher layer. Programmers call it as an IDE, an integrated development environment. So we don't have to work blindly or in the console. So I will launch R Studio. Let me also double check. Take a while. I hope I did not put in. I did not put in my iris classification. I will do that in the data analytics session tomorrow, because it will take time to look for it. Sige, let's go to our next demo, which is also R anyway. So we'll forgo iris species classification. We'll do this. This is related to data analytics anyway. We'll do this tomorrow. So we'll do profiling. Okay, so this is also in R. So I have here two demo codes for R. So this is what the R IDE looks like. Here is the text editor. This is where we type in our scripts, our code. And then this is the console. And then this is the global environment. And here we'll see plots, packages that we need to install. And this is also where we pull up the help. So for running R, for those who would still be venturing in R, it's a good thing to learn. It's very easy to learn. There's a bit of learning curve in the beginning, but it's not that difficult. So where you put your cursor, then you click this button which says run. It means that is the script that you're actually running. So I'm loading the data sets that come with the basic R package. And then you can also run codes that or scripts that span multiple lines. So you can highlight that and click run, but I won't do that. Dim shows us the dimension of the data. We will be working with empty cars. So now, let me pull up what empty cars is, what the motor trend cars is. I am here in the console. Look at my mouse. Look at my cursor, So to pull up help, we just type in our question mark. This will apply for any code that you want or data set that you want to pull up a documentation for. So let's type empty cars because you want to read about this data set. And then I press enter. It will show up our documentation on the motor trend car road test. So apparently, the motor trend car road test is comprised of 32 observations of 11 numeric variables. So it's a collection of data set of maybe vintage or classic cars, not belonging maybe to the vintage category yet, just classic cars. So we'd like to find groupings of the cars in this data set. Dim shows the dimensions, how many rows and how many columns. Let's see if we'll get 32 and 11. So when I click run here and my cursor is here, the result will be displayed in the console. So I'm clicking run now. And if you see here in the console, correct, as expected, we have 32 observations and 11 variables. Now I'd like to display the first few rows of my empty cars data set, and I will use head for that. So there you go. These are the first few rows of my data set. I have a Mazda RX-4, Mazda RX-4 Wagon, etc., etc. Summary will give us descriptive statistics per variable. So we have, say, for example, for the variable MPG, we have a minimum value of 10.40, max of 33.90, median and mean, first and third, our quartiles. No? So then for clustering, dear colleagues and students, it's important because if you recall, we will be computing similarity by looking at the distance. So it's really essential that they sort of fall in the same range, no? Because say I have an attribute that ang range would be, say, age. Range of my employee's age would be from 18 to, say, 60. And then annual income would range from, say, 30,000 to 100,000. So looking at the disparity of the range of the age variable and the annual income, how could you graph that in the same space when they're not of the same scale. Hence, for clustering, it's important that we normalize them and we put them in the same scale. So we do mean centering. I'll just run that. So this is actually just scaling them. If you look at the values here when it's not scaled yet, let's do a summary of the Z. Oh no. Oh no. There. So let's do a summary because I want to see descriptive statistics of the Z now, which is the scaled data set. Now we'll see here. Where did it go? Did I run? There. So you'd see that they now are like, they now have the same scales. No? So it's logical to compute their differences, their similarity, which in the same space. So now we'll calculate this similarity. We'll not print anymore. We're not learning syntax anyway. So we'd like to look at a cluster dendrogram, one visualization. And so let's zoom this so that we'd appreciate what clustering did. We said that one type of clustering is bottom up. So it says that the Hornet 4 drive and the Valiant have similar characteristics, and Merc 280 and Merc 280C, which is not surprising because they're the same make, maybe not just the same, not exactly the same, but they have the same make, not exactly the same model. That would make sense that they'd be clustered together. And then you have another Merc 240D and Merc 230D. And then there's another layer where you find clusters naman that are similar to each other. So you end up having 2 clusters, or you want to stop having just 1, 2, 3, and 4 clusters. That's how clustering is. So that's one kind of clustering. A second demo is, if you recall, dear colleagues and dearest audience, I'll just run this so it's fast. We have a fictitious company earlier creating profiles for their clients. So we want to cluster those. I'm setting my working directory here so that I can choose my data set, which I have previously created. So I will choose ABC. I hope it's here. It's here. So this data set contains the profile of my clients. I will put it in a data frame, view the first few rows of my data set. So I have this person, if you recall him, is our example. Sorry for the typo. And other clients. So I will also summarize to understand the values that I have. Now I'll only look at, I'm only interested in age, income, and number of children. So I'll create a subset of my data frame. Then I will scale so that they're on the same scale, age, income, and number of children. And so initially I do 2 groupings. And visualize the 2 cluster groupings. The 2 cluster results. So there you go. I have this group of people. These are the IDs of these people. So I'm able to identify them and look how they differ maybe according to age, and what did I say? The other one was income, because this is just 2 dimensions. If I wanted to add number of children, it will be 3 axes or 3 dimensions. So if you recall the plot that I showed earlier, this might take quite some time. So this is how we do this and present the visualizations comparing. What if I group them to 2, to 3, to 4, and to 5 clusters? So while it's loading, while our plot is loading, it's still running. You see this icon here. It should load now, which is taking quite a bit of time. So there. So we have gone through this a while ago. And just to recap, what you want are well-separated groupings. We don't want something that overlaps. Okay, so as a decision maker, I might end up as part of, as a KTC CEO, I might tell my people, tell my teams, to come up with 2 personalized portfolios and launch them, these products, or 3 personalized portfolios for these different profiles, right? So that's cluster analysis for us. Yeah, this is an interesting question. I'll answer that in a while. So our next, we have decision trees and surviving the Titanic. In the rapid minor example or clip that we have watched a while ago, they used the Titanic. It's a popular data set. There's a Titanic competition in Kaggle where you would create models that would have the best, you would create best performing models. So that's a data science competition. Nga pala, students or professionals join Kaggle data science competitions. No, it's a good thing to have on the portfolio. So we'll now implement decision trees using the Titanic data set. We'll use Weka because it's lightweight. I hope I did not close it. Where are you? Weka. Let's close R now. And then, whoops, I closed Weka. And then after Weka, just one more demo. And I'm so excited about that because that's NLP and that's Python also. If only I can remember what I was trying to do. No. So we'll open Weka because I closed it. We'll work with the Titanic dataset, which is, I think, in ARFF format or CSV. We'll know in a while. Just ignore that. We'll open file. We'll go to our folder. Titanic, so it's in ARFF format. That's format native to Weka. We'll select that. And then here we have the attributes that we have. So it's the passenger class, kung sa first class ba or saang class siya na pasahero. And this is what we're trying to predict, nag-survive ba or hindi. In Weka, what you can do is you can I'm doing a right click and choosing attribute as class because this is our class attribute. This is our Y. This is what we want to predict. This is human supervision. This is ground truth. So we have name, which we don't want. So let's remove name. So what if this is the number of siblings on board with parents and children on board? Let's not use ticket anymore. Let's not use the destination, body, boat, embark. Let's just select a few anyway. This is just demo. So we're trying to predict survive using the passenger class, the sex, the age, and the fare. So let's use decision trees, which are found here in trees. You can use any of these flavors. I'll use the classic J48. Let's start. And this is our confusion matrix. We have the diagonals are our correct classifications. We have some bad performance here. We said it's an A when it's actually a B. We said that though these persons will not survive, but they survive. That's a good mistake. We said these persons will B is survive, but they did not survive. That's unfortunate. But what I would like to show you is this decision tree, because this is more intuitive than looking at how it's done here. Again, programmers, you can implement decision trees in your apps. These are just if-then rules with ranges. So you will end up with information systems that are machine learning enabled. No? So that calls for a promotion if you're able to do that. So it says here, if we interpret this, that the survival of people is primarily determined by if female or male. Pag female siya and then passenger class is less than or equal to 2, then more likely mag-survive sa nasa first class, no? Pag greater than 2, nandun sa mga economy, depende din sa fare kung mag-survive or not, no? And then we also have this, if age is mas bata and nasa first class, mas mag-survive. Pag bata na nasa may pangmasa, will not survive. I don't like this, this problem. It's so prejudiced. Okay, but this is how we will interpret decision trees. Anyway, di ba when you watch the Titanic movie, it really enforces class in society status. So that's why we just inherit that problem here. So finally, we go to Python. We're almost there, but this is something that you'd enjoy, I hope. So we'll do collab, and we'll do question answering, or we'll just do question answering because we're running out of time. I'll just install transformers. And while we're installing the deep learning libraries we need, let's answer some questions. What's the difference of using Python programming and Weka data tools in crunching big data? Is there any difference po ba? If you're able to do Python programming, do Python programming because it's more robust, you have more legroom, but Weka can also do the job for you. It can generate, it can supplement small data sets, small sample sizes, that it can do that for you. In fact, what you can do in Python, you can also mostly do in Weka, but we'd like to have some pipeline na isang lugar na lang lahat. So if you're doing machine learning in Python, do data crunching and manipulation in Python as well. No? So next, can we increase the leaf of the decision trees by pruning the branches and decrease the likelihood of error in Weka? Yes, click on that space. You can do hyperparameter tuning there. So this one will also take quite a bit. You can still ask questions. This is the last one that's taking so long, promise. This one also pala. Ask questions while we're waiting for this really fancy implementation of Transformer QA. Question answering. So this is deep learning in natural language processing. Almost there, just one more. So we don't have pending questions. I'm sorry if I've missed some. So this is how Python looks like for those who will like to venture into Python. So now we are loading the question answering pipeline, no, from Transformers implementation. So when we're done with that, okay. So now this is where we put in that context. No, I have sample data. This is the National Cybersecurity Plan of the ICT. I'll just need to get it. It's this one also, but I have that in the dataset folder. If you saw that prompt, it says that when you get disconnected, your files will be lost too. So it's always good to maintain local copies. So we have the sample RTF. It's a rich text format. I copied that just from the website. No, and so let's load that context into memory and then ask random questions here. So say, for example, what is this document about? So it will find answers. And you can ignore these numbers. These are probabilities that are computed under the hood. But look at the answer, dear colleagues. It answered correctly. It says the National Cybersecurity Plan. Even if in the document, we don't find this question at all or this statement at all that says this document is about. Walang ganon. No? So what if we say, what does CICC mean? So it has a high score. We do not have this in the document also that says CICC stands for, but it was able to find the correct answer. Cybercrime Investigation and Coordination Center. So we can also ask class, what are the goals of this plan? Of course, this is there, but not in question form. So it's not really the crude string matching that implementation that we programmers from the old school are used to, no? So the plan is about assuring the continuous operation of our nation. It just cut it short. What if we ask something that's really incoherent? Like say, who is trending today? So it's not in the document. It will try its best to find the answer. Then it will give you an answer that it can infer from the document, but does not really sound right. So there would have been other, so I'm unsharing my screen now. That's the a walkthrough of the tools of the trade and the use cases. And I'm opening the floor for questions and answers if you have still more questions or answers. But if none, I will now turn the floor over. I'll turn you back to give you back to our DICT officials.
Thank you very much, Dr. Michelle Banawan. So wala ng question. Siguradong naintindihan naman po talaga ng ating mga participants with your extensive walkthrough and demonstration po. Ako rin po na-amaze na ganun pala yun. Okay, so yeah, thank you very much. Ang galing. May pahabol pong question, ma'am, from Sir Rodney Estrada. Good day, ma'am. Just want to know your insight about the future of data science. Any thoughts po?
Yes, so my personal insight on the future of data science is that it will invade daily life, it will invade institutions, and it's a challenge for all of us to tap into the data that we have. Let's not just be users, consumers of what people will put out there. Let us play an active role and use the insights and wisdom that data science can give us to transform society, to transform, to recover from the pandemic, to see the pandemic as an opportunity and use data science towards recovery, transformation, business re-engineering. So data science is still the sexiest job in the 21st century and will continue to be.
Ayan, so there you have it, our insights from our resource person, Dr. Michelle Banawan. So guys, baka gusto nyo nang mag-switch ng career to data science. Ayan. Okay, I think we have additional questions. Ito si Sir Jeremiah, napaka-active po sa ating Q&A. How will we be able to explore more on these tools po? Do you know where we can get assistance or guidance as we venture into data science, the monitoring of our work and such?
Yes, I also appreciate your active participation, Sir Jeremiah, Maggie Ramos. I've been seeing you guiding me through the discussion throughout the webinar. So there are a plethora of resources that we can use for data science. We have LinkedIn Learning for that. We have those courses. We have also YouTube videos. They would be very useful on specific tools. You go to the websites of these tools because they're promoting the use of their tools anyway. So they have their own transfer learning mechanisms. So for a piece of advice for those who want to enter the field of data science, never stop learning, never stop being excited of learning something new every day. Courses that are free for us to enroll in. There are a lot. So go to GitHub, go to Kaggle, There are a lot of collab notebooks that are available. Go to Scikit-Learn. They are all available for us to simulate and push us towards our career in data science.